This conference will now be recorded.
קליין, לשעבר העוזרת האישית של ארנון מילצ'ן. אנחנו עושים כתבינו תמר אלמוג, עמוס שפירא, סולימן מסוודא ועמיחי שטיין. ראש השב"כ רונן בר נפגש עם ראש הרשות הפלסטינית אבו מאזן ביום רביעי בשבוע שעבר. הפגישה התקיימה בביתו של אבו מאזן ברמאללה. משירות הביטחון הכללי נמסר כי הוא אינו מתייחס לדוח הזמנים של ראש השירות. אנחנו מוסרים כתבינו גל דרגר איתי נומנטל. בית המשפט המחוזי בתל אביב הרשיע את יצחק אברג'ילי בשלושה מעשי רצח של אזרחים חפים מפשע ובניסיון לרצוח את זאב בורנשטיין. בהחלטתם כתבו השופטים כי אברג'ילי עמד בראש ארגון פשיעה עוצמתי ששלח חבורות הן בישראל הן בחוץ לארץ ועל פיו נשק דבר. בפתח הדיון אמר אברג'ילי כי הציבור נותן אמון של 7% בבית המשפט והוא לא מעוניין לבוא לדיון הבא. כתבנו דניאל אלעזר מציין כי הדיונים בפרשת 512 שעסקה בפשע המאורגן נמשכו כ6 שנים. בית משפט לציון העריך עוד ב7 ימים את מעצרו של דניאל אלעזר בחשוד ברצח יזם הנדל"ן אלדר פרי ברחובות בחודש שעבר. כתבתנו עדת טנדר מציינת כי אלדר בן 64 מיליון רכש 2 דירות בשווי 6 מיליון שקלים באחד המיזמים של פרי. תחילה הכחיש אלדר בחקירותיו את החשד נגדו, ולאחר מכן בחר לשתוק. שרת החינוך יפעת שאשא ביטון אומרת כי מבחני המיצ"ב ישמשו אך ורק את בתי הספר ואת משרד החינוך, ומה שהיה בעבר אינו נכון היום. השרה כתבה את הדברים במכתב למזכ"לית הסתדרות המורים יפה בן דוד, לאחר שזו הורתה למורים שלא לשתף פעולה עם המבחנים בחודש הבא. החלטנו השנה על מתכונת שונה של המבחנים, אני חושבת במצב הייחודי. כתבה לירן קוז'ינוב מציין כי בן דוד כתבה אתמול בהודעה למורים שאין לשתף פעולה עם המבצע, הציעה התעלמות במשרד החינוך מהמבצע להוסיף תקנים ליועצות ולפסיכולוגים ולהוסיף שעות לטיפולים רגשיים. באוגנדה נהרגו לפחות 2 בני אדם ונפצעו לפחות 24 בשני פיצוצים שהיו במרכז הזירה קמפאלה. אחד הפיצוצים היה ליד בניין הפרלמנט והאחר סמוך למטה המשטרה המרכזי. כפי שאין עוד פרטים. עורכי החדשות עמית שניידר וזוהר תודה. מחר יעלו מעט משעות החום משעות הצהריים.
Can you hear me?
ביום חמישי בלי שינוי של ממש.
Yes.
We hear you.
Yeah, doctor, please carry on. Please click on the mic button to mute yourself.
כשאבא חלה, דאגנו לבריאות שלו, וזכותי דאגנו בנסיבות.
ההורים הפכו לסיפורים פוחדים חמישי ב-15 יום. כאן רשת ב'.
Hello, everyone.
Hello.
Well, since I hope everyone is here and we have a lot to cover, we really should begin today's webinar. I really appreciate you all for attending today. A very good morning, good afternoon, and good evening to one and all present here virtually with me today. Let me introduce myself. My name is Elena Jones, Conference Secretariat at Coalesce Research Group LLC, and I will be available for any of your queries or questions throughout the webinar to help your technical and organize the webinar successfully. And I would like to thank all the attendees of participants of today's webinar. Hope you all enjoy the webinar and gain knowledge from the sessions today. We also hope your participation will contribute to new research findings and that will lead to new collaborations and research initiatives. Before we start with the sessions, I guess some of you will be new to GoToMeetings app. Let me just explain you the most important tools required for the presentation. On the GoToMeetings app web page, you can find your icons at the bottom center, mic, camera, and screen, and end button. So mic button, click on that to mute and unmute. I request you to all stay muted while our speakers are presenting their research work so that it does not cause any disturbance to them. Camera button. You can use this button to share or unshare the web camera. If you have the option to share the webcam, if you can do it, it will be completely your choice. Screen button. You can use this button to share your screen. This is the main part during your presentation. After I call your name from my side, I will be making you the presenter, and only I give the permission you will be able to share your screen. So once I make you the presenter, you can click on the screen button and you will find a pop-up window to share your screen. And this is your fourth icon where you can use to leave the session. On the top center, you can use the top options to change your display settings. At the top right corner, you will have three icons: people, chat, and setting. In the chat option, you can chat with me or any other participants. For the settings, you can use this button to check for the setting of your speaker or microphone. So as mentioned, kindly remain muted during the presentation so that the presenters doesn't get distributed for any questions, or you can ask the questions, or you can send your questions in the message box too. Well, let's not take much of your time. Finally, I would like to request you to please give a brief introduction about yourself before starting with the session so that we can know about virtually. So let's move on to our sessions. The first presenter is Dr. Luxas Rojek, University of Applied Science, Germany. Hello, doctor. Are you ready with your presentation? Hello, Dr. Lukas Rosek.
Hello. Yes, I'm ready with the presentation. Yes.
So perfect. Now I am making as a presenter. Please share your screen.
Just a second. I just open my presentation. Okay, please let me know if you can see my screen.
Yeah, we can able to see your screen. Yeah.
Okay. So should I start my presentation now?
Yes, you can start. Please continue with your presentation.
Okay. Hello, everyone. My name is Łukasz Rojek. I'm a PhD student, not a doctor yet, at the University of Bamberg. I'm also a research associate at the Berlin University of Applied Sciences. Since 4 years, I was working on a project that was financed by a Federal Ministry of Food and Agriculture in Germany. We developed a multi-sensor network-based monitoring system for resource-efficient and automated irrigation of crops. And today, in my presentation, I would like to present you our prototype and also to share our experiences and also results from our project. Okay, so about the project idea and the objectives, the water is a vital resource for the agricultural plants. So the water supply has a huge impact on the quality, on the growth, healthiness of crops, especially in organic plant productions. So we decided to develop an intelligent plant monitoring system. And by intelligent, I mean a system where the data collection, data analyzing processes, the visualization, and also the controlling, the whole control of the actuators happens completely autonomous, so automatic. And the short diagram you can see on the left side, it's unfortunately only in German, but these are the 4 steps that I already mentioned. So translated in English, it means that we are collecting all the data from the measuring sensors. Then in the next step, we are sending those data to the central server for analyzing processes. Then the user has the possibility to see all the results in the web application. So the visualization happens in the web application. And at the end, we are irrigating the crops. And it's a non-contact measurement, which is very important, what is very important for the plants. And the irrigation happens on demand and also targeted irrigation. So we will be only irrigating the area where there is a water stress. For that, we need a very precise georeferencing, very precise positioning system, so we can estimate the location of the plant that are under water stress. Our prototype is visualized on this image. So for now, we are testing the prototype in the greenhouse of the university. It's mounted on the rail system on the roof, and moving between the tomato plants, continuously collecting images from the upper part of the plant. So as I already mentioned, the images are being sent in the real time to the server. The server is also located at the university. We are analyzing those images completely automatically, and then putting the results to this web application, sending also the output signals to the water pump for irrigating the plants on demand and also targeted, so only into the boxes where the plant is under the water stress. Those devices can be divided into 2 groups. So we have the group of sensors and group of the actuators. The sensors, we are working with the optical sensors in different wavelengths. So we're using a combination of different camera systems that are combined together. So those cameras are doing the measurements, sending the images to the control unit. The user, the customer, has still the possibility to change the logic of the program. It can define some kind of boundaries, it can define limits, it can define rules. And according to those settings, to those rules, the control unit is making decisions. The decision about if to turn the water pump on or off. So if we have to irrigate the crop or not. The control unit is giving the output signals to the actuators. In this case, it is the water pump that is irrigating our tomato plants, but it's also giving the outputs, the results to the web-based applications for the user So the user has the possibility to follow all the steps in the real time, what is happening in the system. For the system architecture and the implementation, we divided this into the two parts. The first part, which is a quite easy task, because we are using the network of the university. So we created our own local network in the greenhouse. As you can see, it's we have our multi-sensor measuring system. That's the one device running in the greenhouse, and the other one is the weather station, collecting all the time the information about the environmental conditions. Those information is sent to the central server over the network of the university. So there is no problem with the data transmission anyhow. But in the second phase, we are trying to put our system onto the drone. So right now there is the second project running, where we are trying to put our already developed prototype onto the drone. And in the open field, it is a huge problem for sending the data, for sending images to the central server, because the size of the amount of data is quite big, and it's not really efficient, and it's also not that easily doable to send it over the LTE. Or we are hoping that we could use for it the 5G connection. Or the other possible way would be to reduce the data on the field. So during we are collecting the data, we will be reducing those data and only sending the indexes to the central server. So that would be a possible solution to solve this problem with the data transmission in the open field. For the communication, we decided to use the message queue telemetry transport protocol. It's a very lightweight protocol that can be used also for the small devices. It's based on the principle of publishing and subscribing. So the huge advantage of this protocol is that it can combine multiple sensors at the same time in the real time. All the sensors can communicate with each other, and each message is assigned to some topic, and those devices that are subscribing for this particular topic will receive this message. So the principle is very easy, and you can send simple data over this protocol. So in our case, it's the information about the timestamp, of course, the measured value. That could be the temperature, that could be the humidity. We are not sending image data over this protocol, only simple actions like turning the motor on, turning the motor off, or starting the camera, starting the measurements, and so on. So it's, as I said, a very lightweight protocol. That it's the huge advantage of this communication method, and it can be used also for very small devices. The multi-sensor measuring system itself, it's built like described on this image. So we have two sections. In the upper part of the system, we have our control unit. That's the Jetson Tegra TX2 version of NVIDIA, combined with Astro Carrera motherboard. We have also two motors. The first motor for moving the system forward and backward, and then the second motor for rotating the camera by 360 degrees. Of course, two batteries for charging the control unit and also for charging the camera system. On the bottom, we have the combination of the thermal camera, of the visible near-infrared camera, and the short-wave infrared camera. Okay, so the bottom part, as I said, can rotate by 360 degrees, so we can monitor the plant from every angle. Then the positioning sensors, it is a combination of the inertial measurement unit and the stepper motor. It's the method of dead reckoning. So it means that the stepper motor gives us the information about the distance, and the IMU system is providing the information about the direction. So based on the direction and based on the distance, we can calculate easily the current position of the system. The system starts at the initial position and it's moving forward till the end position. Then the bottom part, the camera system, is rotating by 180 degrees and capturing the planes from the other side. We have also the NFC markers placed on the rail system just for controlling the position. So if some of the sensors are drifting too much away, then we can detect it by using the NFC markers. For the imaging sensors, we are concentrating on different wavelengths, starting with the visible light and the near infrared light. So the first method is for detecting the plant on the image. So we want to create a mask for the plant objects. So it's possible to delete the whole background. It can be done very easily by combining the near infrared light with the red light for calculating the normalized differential vegetation index. Then for detecting the water stress, we are concentrating on two other methods. The first one is according to the temperature of the leaf. It's named crop water stress index. So based on the temperature, the current temperature of the leaf, we can calculate the stress index of the plant. But for this method, we need two extra information about the maximum and about the minimum temperature of the plant. And these two values are changing every day, so they're changing according to the environment. So depending on what is the air temperature, depending on what is the humidity, it can change even by a couple of degrees. And the last method is the normalized differential water index method. We are combining the shortwave infrared light in the wavelength of 1300 nanometers and 1450 nanometers. The first wavelength is reflecting the water, or the water is reflecting this wavelength very much, and by 1450 nanometers, the water is absorbing this wavelength very, very strong. So if we combine them and if we normalize them, then it will be possible, or it is possible, to calculate the water index or to detect how much water is inside the leaf of the plant. So the whole process is quite complex because before we can start analyzing the images, we have to prepare them. We have to extract only the wavelength that is interesting for us. We have also correct the data, delete the noises, or convert the digital signal into the temperatures, like for the thermal imagery that it's done. But the point is that the method 1 and the method 2 are being compared at the end. So we are comparing the results coming from the water stress detection with the first method with the results from the water stress detection from the second method. And if both methods are telling us that there is a stress at some particular time, then we exactly know that we have to irrigate the crop. But if there are some kind of differences between those two methods, then we have to go into the details and check the measurements. Okay, this is only an example for the NDVI method. How is it done? So it's based basically on the right, on these two images on the right side. You can see what happens if you have a vital vegetation. That's the dotted line, and the solid line is representing the stress vegetation. So comparing the visible light and the near infrared light, you can basically detect objects where the vegetation is very high and separate them from the objects where the vegetation is very low. That's the method how you can separate the plant from the background. So as you can see by the plant is reflecting the near infrared light very much, and it's absorbing the visible light. So what we could do is to switch the blue channel in our camera. In this case, we are using the Raspberry Pi camera without the near-infrared filter, and we are switching the blue channel with the near-infrared channel. So the near-infrared light is stored in the blue channel. The result of that is, of course, this kind of image. So the plant is no more green on the image, but it's getting the blue color. And then it is by converting this near-infrared image into the NDVI image, we are getting this kind of result. So we are getting indexes between the -1 value and +1 value. Everything above 0.2 is representing the plant. So it's not a problem to convert the second image into the binary image that is our mask. And this mask will be put it onto those two another images coming from the shortwave infrared camera and coming from the thermal camera. By the thermal camera or by long wave infrared, we have an additional problem because we have the atmosphere between the camera and the plant, or between our object that we are trying to monitor. So we have to definitely measure also the atmospherical circumstances. We have to estimate the current temperature, the air temperature, the humidity, because based on that we can calculate how much energy reflected by the plant is coming through the atmosphere into the camera system. The atmosphere itself is also producing energy, it's also producing heat, so we have to consider this as well. And another parameter is the emissivity, because each object does have another emissivity, and for the plant is, for example, 98%. So it means that the plant reflects 98% of the energy. Here we see two examples. So what is happening if we will change the distance and if we will change the temperature, what happens by the transmission of the atmosphere. In the greenhouse, it is not that important. It's not that important because the distance to the plant is very, very small, so it's not even 1 meter. But outside with a drone, we will be flying at the height of at least 20 meters. So we can see that by the temperature of 40 degrees and by the distance of 20 meters, we have already the transmission of 95%. So we are losing 5% of energy that it's or of the temperature that it's produced by the plant, that is reflected by the plant. The same simulation, but for the humidity. So as you can see, by the distance of 20 meters and the humidity of 50%, we have the transmission of 97%. Okay, that would be another example how to detect the difference between irrigated plant and the stressed plant. So on the right side, this is on the left side, you have an original image coming from the thermal camera. Then in the middle, you have already pre-processed image. So with the binary mask put it on it, and so it was possible to extract only the plant out of the thermal image. On the left side, you have the stressed plant. On the right side, this is the irrigated plant. And so already based on the colors, you can see the difference, but on the histogram, it is detectable even better. So the difference between wet and dry leaves is even approximately by 2 Kelvin, by 2 degrees. For the shortwave infrared, we have to use 2 filters. So our multispectral camera is measuring, it's a snapshot camera, it's a simple snapshot camera that is sensitive to the wavelength or is to the wavelength between the range 900 nanometers up to 1700 nanometers. But we are only focusing on 3000 and 4050 nanometers, where the water absorption is very low, and where the water reflection is very low. That would be 4050 nanometers, and by 3000 nanometers the reflection is very high. So that's why we have this filter in front of our lens. So we are putting one filter for images recorded in 1300 nanometers and one filter more for the images recorded by 1450 nanometers. Okay, this is our system can also be used stationary, so you don't have to put it on the rail system. You can also use it as a stationary system, and this is only an example how we have implemented in the greenhouse, so for the tomato plants. Our goal is to reduce the data, as I said previously. In the open field, we will get the problem that we cannot transmit the images in the real time because the amount of data is too big to be transmitted over the internet. That's why we will be trying to reduce those data to a single value, presented here. So there will be only a single value for a single image assigned to the timestamp. That was an example. It is an example for the results that we have done last year in summer. Based on this measurement, a short explanation because it's also unfortunately only in German, so I will translate it to English. The blue line is representing the crop water stress index. Then the orange line is representing the water index, and the gray line is representing the transpiration of the plant. So you can see that starting from 10 past 10, the transpiration of the plant is decreasing. So it means that the plant is sweating. So basically the temperature should be increasing and also the water stress should be increasing. And this is visible on these two lines. So we are just looking for those peaks. We're looking for those high changes, high values in both methods to estimate the irrigation time. So in this case, both methods gave us the result that at the time 10:30 we should irrigate the system. There's a very small difference. The one method said 10:30, the other one 10:35. But it's still in the tolerance, within the tolerance. For the user, the visualization should be looking like this. So the user should be able to do any changes to the system. It can see all the images in the real time. It can also go to the previous measurements and can analyze them by himself. Also, all the control aspects are given in the web application. So it has the control over the whole system. And as I said, right now there's the second part of the project running, so PlantSense 2, that's the following project, also financed by the Ministry of Food and Agriculture for the next 3 years. And in this project, we are trying to put our prototype onto the drone. So what we need is, of course, the optimization of the dimension of the weight and the power consumption. In the greenhouse, it's not a problem, but for the drone, these are very important aspects. The precise georeferencing in the greenhouse is done by using the inertial measurement system in the combination with the stepper motor. For the drone, we will be using the real-time kinematic GNSS system and combining with ultra-wideband system. Then we need the stable data transmission of image data over longer distances. This is a huge problem outside. If you don't have like a stable access to the internet, to some network in the open field, that's definitely a difficulty. It's a challenging part of the project. Okay, and also we will extend our system by using another camera, the hyperspectral imaging camera, for the diseases detection in the plant. So we would like to analyze the healthiness status of horticultural crops. This table is just a short overview over these two projects, PlantSense 1 and PlantSense 2. So the first one is rail-based, used in the greenhouses. The second is a drone-based system, also for outside. We have different positioning methods. We have different telemetry methods. We are using also different camera systems. Okay, so I'm done with the presentation. Thank you for your attention. And if you have some questions, then I would be glad to answer to those questions.
Thank you for your presence and presentation, Doctor. Is anyone having any questions?
There is also a short video that I could show you how the system works in the greenhouse. So if there is still like 2 minutes of time, then I could show you the video. Would it be possible?
Yeah, you can share your screen.
Yes, just a second.
Okay.
Okay, so I have the video. I hope that I can share my screen so you can see it. Just a second. I'm already selecting the screen. So please confirm if you can see my screen.
Yes,
can you see my
Doctor.
screen? Okay.
Yeah.
Okay, so this is how it works. As I said, the system is moving between the tomato plants. It's mounted on the rail system on the roof. Then that's the web application, the interface. The user can see all the images in the real time. So the thermal images, the shortwave infrared, and also the images coming from the Raspberry Pi camera and the VI images. You can also use the tablet or any other device to control the system fully. You can stop the system. You can change the moving direction. You can change the speed, so the user can still decide how fast the system is moving, how many images are you collecting for each session. So as I said, the user has a whole control over the system, right? But still the system is analyzing the data like automatically or autonomous according to the settings or according to the rules that have been defined by the customer. Okay. So thank you once again for your attention.
Thank you, Doctor. Thank you for the presentation. So let's move on for the next presentation by Dr. Marek Schlinger, Celsian University of Technology, Gliwice, Poland. Hello, Doctor.
Hello.
Are you ready with your presentation? Hi.
Yes. Okay. I try to.
Okay. Now I'm making you as a presenter. Please share your screen.
Okay. Yeah. Okay. Okay.
Yeah, we can able to see your screen.
Okay. Wait a minute. No. Okay. Now should be the
Yeah,
screen,
perfect.
yeah?
Please continue with your talk.
Yeah. Okay. So good morning, everyone. I'm working on Faculty of Mechanical Engineering in Celsian University of Technology, and it is located in the city Gliwice in Poland. The city Gliwice belongs to the Silesian region. Okay, wait, sorry, but I have a problem to change the. Okay, sorry. So the Silesian region, it's located in the southwest of Poland. as Salesians, we have the specific dialect, very good food, and we are very hospitable. So I recommend the visit. It could be a good place for you to see something new and meet new interesting people. But back to the topic, to the presentation. As a highly industrialized region with a lot of post-mining areas, the issue of environment and the removable energy sources are extremely important to us. So today I would like to talk about the possibility of increasing the efficiency of silicon solar cells by using the thin film deposited by atomic layer deposition method. So the removable energy sources are not alternative to the traditional non-removable energy sources. Their resources complement each other in the natural processes, which make them practically insustainable. So obtaining energy from those sources is more environmental friendly than the traditional sources. We can often came across the view that the solar energy is not a real removable energy sources because the sun, like every star, will go out and at the same point. So therefore, I would like to present you the life cycle of the sun and indicate where we are now at the moment. So in my opinion, we can easily say that the photovoltaic for us is a removable source, energy source. And the photovoltaic is the field of science and technology dealing with the processing of sunlight into electricity. Conversion of the solar energy into electricity is possible thanks to the photovoltaic device that we are called solar cells. Photovoltaic is largely used in the places that are difficult to reach for traditional energies, such as remote mountain resorts, boats, buoys, or, for example, road lighting. But it also often became now the main source of the energy in residual normal home. Today's photovoltaic market is dominated by technology based on the silicon and the other inorganic semiconductors. Crystalline silicon solar cells account for more than 83% of the total production of solar cells. Because we have not yet achieved the theoretical efficiency of those solar cells, it is still worth studying with this technology, despite that already known perovskite or day-synthesis solar cells, which are still far from the replacing silicon solar cells. The technology of manufacturing of silicon solar cells is complex and consists on several stages. In the silicon solar cells technology, a step of deposition of after reflection coatings is very important, and that's why I will be focused on my presentation on this today. So the energy losses resulting from the incomplete absorption of solar radiation and the electricity generated in the solar cells affect the most important utility parameter of the solar cells, which is the energy efficiency. About 36% of the losses is due to the reflection of the light radiation from the outer surface of the solar cells. And the anti-reflection coatings minimize the light reflection, thus increase the efficiency of the finished solar cells. So in the literature, the values of the materials are widely described, but for us, for now, most interesting it's aluminum oxide, titanium oxide, and zinc oxide. And normally the anti-reflection coatings are deposited by vacuum method, especially physical vapor deposition. But there we have a lot of problem because earlier we need to prepare the texture and the surface of our solar cells, and when we use the PVD, particularly we covered those texture. That's why we in our work we use the ALD method, atomic layer deposition method. And so the part of the goal of my research is to develop the technological condition of the ALD method so that it will be ready for the use in, for example, in the photovoltaics application. And in our laboratory, we work on the ALD reactor R200. It's from Picoson company. We have two sources for the liquid precursors. One source for solid. This one we can see here it. And this one must be additionally heated, and we have one source for the gas precursor. Thanks to this, we can deposit multi-component layers, whatever we want to get. Since we don't have the plasma, temperature is the most important parameter for us. If it's too low, the material may condense and we didn't get the uniform layer. And if it's too high, we can lead to the decomposition, and the growth cannot start. So here is in the table, I provide some examples of the material that we can obtain thanks to our system, and mark in the red those one which have already experience. So like you see, we usually use the oxide metal, but sometimes the metals or other complicated materials. In the ALD method, the precursor and the reagent are introduced separately, and between this, the chamber is purged with the inert gas. Thanks to this step, one monolayer theoretically is created. By repeating those steps, we can obtain the layer with the planned thickness. Thanks to this solution, we can control the thickness of the layers at the nanometric level, and because the substance fills the entire chamber, we can evenly cover all the elements, even with the complex shape. So on the basis of our preliminary study, a significant condition of the thin film deposition we are established, such as, for example, flow rate or carrier gas, flow rate, the time of introducing the precursor into the chamber flushing time, etc. For this one, I present the table for aluminum oxide. It's the precursor trimethylaluminium. It's the metal organic compound, and he react with the water and give us the titanium aluminum oxide. We start with the aluminum oxide because it's a very interesting material. I will talk about it in the next slides. Here is some conditions that some experiments that we do. We change the temperature of our processes and the number of cycles, and we also introduce some additional heat treatment after the deposition here. Why? Because when we deposit the anti-reflection coating, it's one of the end steps. We need to deposit metal contact. The metal contact usually is we do this by the screen printing method, and in the production they do this too, this method. And after screen printed, it must be fire up, so in the furnace. So earlier, when normally was used some materials that are thermal stable, there wasn't the problem. But when we start use the aluminum oxide, or for example zinc oxide that thermal unstable, those additional temperature could influence on the properties and on the crystalline structure of those materials that why we want to check it. And the surface morphology of this prepared samples we evaluate, for example, by the atomic force microscope. The deposited thin films are characterized by a low roughness. Even when we use the additional heat treatment, we see that the surface development increase, but still it's not a bad result. Also, the diffraction image made in the transmission electron microscope indicated the thermal instability of the aluminum oxide thin film. It can be seen that the beam influence on the structure and transform from the amorphosis or finally nanocrystal into the typical polycrystalline structure. It's aluminum alpha in this case. The same you can see in the high resolution image. You can see how the crystalline structure on the right side it's created. So since the structure is changing, so the optical properties also need to change. So you can see that the refractive index is changes. Having, for example, this kind of knowledge that the additional heat treatment influence on our properties, we can optimize the process of deposition of anti-reflection coatings. For example, when we have the when the heat treatment give us higher refractive index, for example, we no need to have so thicker layers, so we can shorten the process, or we can get the lower, for example, cost of the processes. So it could be very important. As in the consequence, when we increase the we can increase the efficiency of the silicon solar cells only to control the heat treatment even more than 1%. So it's very, very important. Okay. Okay, here I want to show you the breakthrough of the silicon solar cells with aluminum oxide layers. Was made by scanning electron microscope. It can be seen that thanks to the ALD method, the previously made texture with the shape of pyramids is accurately reproduced and not particularly covered up, for example, in the case of PVD method. By combining the texture and the deposition of our ALD thin films, we can minimize the reflection even below 0.5% in the wide range. So practically we don't have the problem with the reflection. The aluminum oxide, it's a very interesting material because it could place the two rules. It could be anti-reflection coatings and it could be passive layers. So it's very interesting because not only minimize the reflection, but even increase the short circuit current of the silicon solar cells. The changes of the short circular current on the whole photovoltaic cells we registered by Coalesce scan by the method of light beam induced current, and we can see that the additionally process temperature has positive effect on the value of our solar cells. So after developing the aluminum oxide, we also made solar cells with the multi-layers coatings, for example, double layers or triple layers with different composition. Usually used aluminum oxide, titanium dioxide, and zinc oxide. All deposited layers are characterized by the polycrystalline structure. Respectively, for the zinc oxide, it was the Wurtzit, for the titanium dioxide, it was Anatas, and for the aluminum oxide, it was previously say aluminum alpha. Here is in the Polish, it should be in English, sorry, it's krzem in Polish, it's silicon in English, so it should be in silicon. And we also had to determine the optical constants to check if the selected combination are corrected. For this purpose, we use the spectroscopic alixometry, and we can see what kind of refractive index and extinction coefficient we get. And checked if our composition is right from the optical point of view. And from all preparing solar cells, the best results we are obtained with the double anti-reflection coatings, aluminum oxide, titanium dioxide, and its efficiency was almost 90%, so it's very good, I think, results because this solar cells was producing in our laboratory only from us. We are not special with all steps to producing the solar cells. So I think that the companies producing the solar cells can get the better result, use our technology. And so, summarize, we proved that the ALD method can be effectively used in the production of silicon solar cells and positively affect on their efficiency. So that's it. Thank you very much for your attention, and I'm waiting for the questions.
Thank you, Doctor, for your presentation. Is anyone having any questions?
Hello?
Yeah.
Yeah,
Do
hello.
you hear me?
Yeah.
we
Hello.
hear you. Yeah, we hear you.
Yeah, doctor, please continue. We can hear you.
Okay. Okay. Thank you, Mr. Mark, for your nice presentation on regarding the solar cells. And I see your presentation find this very nice. In regarding with the anti-reflection coating, I didn't see on your slide any geometric relation which relates the refractive indexes of the layer. That means the layer, the aluminum oxide, tin oxide, and so on. So what is that relation, or how you omit that relation in this presentation? And the next point, I have also a certain comment regarding this. There is nothing present on your slide regarding with the optical thickness of those layers. So how do you consider those things? And the next will be in what range of the wavelengths your material become optimal or will be nice solar light or light absorber. That is the next question. And the lastly, in manufacturing or fabrication of solar cells, the problem is their stability. So in what way did you treat the stability of your material? Or please say something about the stability of your material. Thank you very much.
Okay, thank you for all your questions. This is very interesting questions and very practically. Yes, of course, I was only mentioned about the spectroscopic ellipsometry. So it was only one slide and I showed the refractive index or all of materials that we are deposit. So it's really need to be combination between the thickness and the refractive index. So firstly, we were need to check what kind of refractive index and we get, and after that we can take the thickness that we wanted. Earlier I was said that the thickness of these layers we can easily control by ALD in the nanometric scale. But still we always check it by the spectroscopic ellipsometry, and the thickness was all of the layers was between the 20 to 80 nanometers. It depends what combination we do, but normally wasn't more than 80 nanometers all the coating with different layers, yeah, multi-layers. So I hope that will be the first question. Yes. The second was about the third was about the stability. Okay, I remember that. After I was talking that the very important was the last step that we need to do. So the fire up in the furnace, the screen printed metal contact, and it was that was seen in our presentation that its influence on our materials, and they are unstable. But when they are goes to the polycrystalline structure, for example, wurtzit in the zinc oxide or titanium dioxide anatase, they are very stable, even more than 90 Celsius degree. So it's not a problem with the normal work of the silicon solar cells. Of course, all of the companies that work with the silicon solar cells always fight with the systems that can be cooled up our solar cells that can work in the normally environment. Okay, and the second, if I could remember, was about the what is the most effectiveness is wavelength, yeah, if I could remember, Professor. For silicon, it's
Yes, of
about
course.
600. Okay, yeah. For silicon, it's most effectively.
That means in order to clear the question, in what range of wavelengths your material would be better?
Sorry, can you repeat it? I don't understand it. Sorry.
Oh, I think in your slide you show, or we have seen that the optical properties versus the wavelengths. Am I right?
Yeah.
Yeah. Okay. So if so, in what range? Yeah, in what range of the wavelengths your material or your manufactured material become optimum or better for sunlight absorber?
Okay. So typically for the silicon, it's 650. So this one always it's take it into the account when the every people at production the solar cells give us the efficiency, but usually for us the best we want to get the best result between 400 to 800. With those range of the wavelength, we want that to get the best results. And our layers, like I show, the reflection give us below 0.5%. It is better than in the PVD coatings that they get about 2% in this wide range. Is it okay for you? Yeah, this answer.
Okay, thank you. I've get all my problem, and thank you for your nice presentation again. Thank you very much.
Thank you for your questions.
Thank you so much. So let's move on to the next presentation by Dr. Gideon Oren, Ben Gurion University of Tel Aviv, Israel. Hello, doctor. Are you ready with your presentation?
Yes, I'm ready.
So now I'm making you as a presenter. Please share your screen.
Can you see it? Can you see?
Yes, doctor.
One moment.
Let's wait for a few more minutes for Dr. Gideon to join. Hello, doctor. Are you ready?
Can you see my screen?
No, doctor.
One
Wait,
moment.
I will make you presenter.
Now you can see it. Share. Now you see it.
Yes. We can able to see your screen.
Okay, is it cut the screen or you can see all of it?
No, doctor, please make it as a full screen.
Full screen?
Yes, on the bottom.
On the bottom?
On the bottom right side, there are 3 buttons. Yeah, the next one.
To the right or to the left?
The last one. There are 4 buttons. There is a last button you need to click. Please click on the slideshow button.
I don't have here.
On the bottom right side, there are 3 buttons. Please click on the 3rd button, slideshow button. The next one and the next one.
The next one?
Yes, doctor, on the bottom right side, there are 3 buttons. After the normal button, please click on the slideshow button.
I cannot.
On the top side, there is a slideshow button, file, home, insert, design.
I cannot see it.
Just a minute, doctor.
What?
Just a minute, doctor. We are making a slideshow.
I'm sorry, I don't.
Hello, doctor.
Yeah, I'm hearing you.
Yeah. Please click on the slideshow on the top header. There is a slideshow button.
Is it on the top?
Yes, is it on the top?
On the bottom.
And after, yes, click on that slideshow. On the top, slideshow button is there.
I don't see the slideshow. One moment.
Yes, doctor. Yeah, we can see your screen. Please continue with your talk.
What did you say?
We can able to see your screen. Please continue with your talk, doctor.
Can I begin the talk?
Yes, you can start.
Okay. My name is Gideon Aron. I'm from Ben Gurion University in Israel, and I will talk about solid waste pumping for improved environmental control and solving transportation problems. The idea is I don't covered here.
Hello, doctor. Is there any?
Yes, I am listening. I am hearing you.
Yeah, doctor. You can change the slide by clicking the left seconds button. 1, 2, 3.
Can you see it now? Can you see it?
Yeah, we can see your screen. Please continue.
And you see the slide?
Yes, doctor, we are seeing your second slide.
Okay. Solid waste, we have to characterize it by different parameters. And there are different types of solid waste. We have machinery, construction, batteries, wood, paper, whatever. And then what is important is a relatively large volume which the solid waste occupies, and the specific weight of the solid waste is something between 200 to 300 kilograms per cubic meter, and of which we can find, as I mentioned before, cans, construction materials, food remainders, and so on. It's a mixture of different kinds of waste, which we get rid of our daily life and of our household. The rate of production of solid waste in our country is about 1.6 to 1.8 kilogram per capita per day. And then we can multiply it by the number of people which we have in each country and get the total amount. And it's still a real problem in our daily life. Now, of course, the amount which is produced by each family or each person depends on local habits and local life and so on. But in our case, it is, as I mentioned, something between 1.6 and 1.8 kilogram per capita per day. If we go one step further, there is a term which is called circular economy. And that is actually, it means that we plan or we try to reach a point where we have zero waste. And the idea is that whatever we dispose as waste can be reused for another purpose. That is a general idea when we talk about circular economy. And here for this, we have analyzed or tried to analyze some of our solid waste systems. And the analysis is based on analytic hierarchy process, or what we call AHP. The AHP actually compares different alternatives, and then we have to analyze the effect of each parameter on the solution. So it is a kind of half theoretical analysis which will take us further forward. So the idea, as I mentioned, is AHP. The AHP, as will be mentioned later, is based on theories which were previously developed by an expert by the name of Sati, and we'll see it later again. And I will emphasize 4 directions of solution. Conventional removal and transportation of the solid waste to be buried, that is the first alternative. The second alternative is conventional removal and transportation to a generation site of energy. The third, the 2 other directions are what we call underground transportation by pipes, which will suck the solid waste into the treatment and recycling site. The first one will be for the burying of the solid waste, and the fourth one will be to use the solid waste for energy generation. Essentially, I have to say that the burial of solid waste was a direction which was taken relatively long in this country, in our country, but now we try to change it into the direction of circular economy, which I just mentioned, and we have to look at the solid waste, which was considered as a nuisance, as a source for any raw material, whatever it is, and that is a general tendency, to my opinion, all over the world. So here we can see some limitation and advantages of the pneumatic system, transportation system, where conventional. I will not go through it. I leave it to everybody's imagination, but it is a direction which is now beginning to take over in our country. We have very limited number of pneumatic systems, but it takes time. It takes time to convince the decision makers, the governmental decision makers, that it is a direction which has to be adopted for the solid waste. Here again, the energy generation, which has some advantages and disadvantages. We have the controlled burning, we have ash production, which is a contamination factor in the burning. We have general air pollution. We have the problem of heavy metals, but some of them can be solved by capturing or collecting of the pollutant in the air and covering the treatment facilities by special means. Here we can see here, I hope you see my mouse, the general approach. I would say that in general, and it is difficult to implement, is to separate the solid waste at the source. And in this case, I mean mainly to find a way to separate the solid waste in our kitchen. So it means we need to have 3 or 4 buckets or collecting baskets for the solid waste, and then to get rid of them by the different system. If we separate it at home, it has some advantage, but I won't emphasize this point now. I leave it for another talk. Here we can see another direction of energy generation versus waste burial, and I leave it again to the audience reading what are the advantages and disadvantages. I have to say the transporting of the solid waste from the production point, namely from the residential area to the treatment site, can be, at least in our case, at a distance of about 30 to 50 kilometers away, which means that we have some air pollution, and we have air pollution, not less important, due to the cars transportation, cars movement, cars maneuver. And that is a real problem. And if we have it in an underground system, all this will not happen. So it increases also the loading of the traffic in the systems, in the main road system. And if we do it underground, and of course, there are a lot of limitation in the financial of such a system, it is a problem. So that is one of the directions. Here again, we can see some of the advantages and disadvantages of alternative burning versus energy production. And now I will move to the materials and methods which we implemented in the AHP analysis in our work. We analyzed current situation, we presented the alternatives, we implemented the AHP in general, and then did some analysis, sensitivity analysis in reference to the different parameters which affect the solution. It is, I mentioned again, that is a AHP analytic hierarchy processes. The idea is in the AHP that we compare pairs of variables. That is pairwise analysis. Immediately we'll see some examples. And then we combine all the data to find out what is the best alternative. I have to admit that it is a half quality and half quantity analysis, and the amount of people or experts which are involved in the decision making, as long as it will be larger, this community of experts, the better our result will be our result. So that is some comment which refers to the AHP. It is, we have to compare the hierarchical versus non-hierarchical analysis. Here we can see the hierarchical analysis, and only please pay attention to the fact that the numbers here are always referring, I have no time to go into details, but the total of the land and quality, which you can see here, is equal to 1. And that is some of the basic idea, and I will take this idea all over the analysis. And now, what is the ranking of the information which we define, and that is part of the pairwise comparison. So we see that it is based on 9 degrees, 9 degrees of quality comparison. And if you can see that A1 or number 1 is that there is no difference in the alternative, and number 9 is extreme preferable alternative, and all the others are some information in between these two values. So now it comes to the point, to the decision, how can we compare it? But it works, and don't ask me why is it 9 degrees and not 11 or 7 and so on, but that is how they, how Sati described his method of comparison. Now, please note what we have here. Here is a comparison. Here in the diagonal, we see always 1. And if we compare here the data, then we can see that if we have here 3, then the suitable parameter above the diagonal here is 1 divided by 3. And if it is here 3, then here it's 1 divided by 3. And if it is here 1 divided by 9, then the 9 is here. And then we have a kind of calculation of the data. We have to find the geometric mean and then the normalized mean, which allows us to find out the best alternative, namely the largest value, which is used here. If we go one step further, here we see how it works. So we have here, but that is arbitrary. We have 6 alternatives which define the quality of the parameters which affect the solution. So damage to the reuse side, environmental damage, air pollution, transportation cost, and so on. And here down in the green squares, we have the parameters which are affected by the parameters which are in the black square. So here I repeat again the 4 alternative, which is, as I mentioned, 2 are conventional transportation and 2 are underground pipe transportation. Both are for burial purposes and energy generation. And again, for the second pipe, underground pipe, again, burial and energy generation. So that is a schematic description, and all of it have to be calculated or is calculated, and we come up with the data which I showed in the previous slides, which was only an example for another case which I just showed for an example. Here we have the final results, which to which we arrived during our solution. So if you look at the results, so environmental damage is the largest fraction in this analysis, and also here damage to the site according to the solution. Here we have also marginal other parameters, which is, for example, potential income and so on. So these are marginal, and that is also marginal. Again, you can see here, we can see here the 9 degrees of the ladder, which emphasizes the solution according to the AHP. Here we can see the final results. We see here we get the number after all the calculation, normalized data. Actually, I hope I did not make here a mistake, that the total numbers here sum up to the value of 1, but this is the value, the best values which we obtained. Also here we have some analysis of the results. Again, we obtained the result that environmental damage is the real damage, and then we can see the schematic description that the transportation to the treatment site with underground pipes has a great advantage over the 2 other 3 alternatives which we refer to. So, and of course, we can check 4 or we can take 6 and so on, but of course, it makes the calculation more complex. But at least here, we can emphasize that underground transportation to the treatment site and creating an alternative source for energy is the best solution according to the data which we considered. And it is important to emphasize that that is our data, and of course it can be changed according to the expertise of the community who is involved in the analysis of the data. Let me come to the final conclusion. We have here the final solution is underground pipes. Environmental damage is the most effective criteria. I mentioned that it will be the best that we separate as a source. That is a general tendency today around the world. And very important is we hope that this kind of approach will be implemented in some way in this country or another one. And I would like to thank you for your attention, and I'll be ready to take any question and respond as well. Thank you.
Thank you, Doctor, for your presence and presentation. Is anyone having any questions?
No question.
I hope no questions. Thank you once again, Doctor.
Okay. Thank you for allowing me to present all information and our data.
Thank you. So let's move on to the next presentation by Dr. Mengistu Jambri. I think Dr. Mengistu Jambri is not available right now. So I would like to call Dr. J. Hunt, Federal University of Espirito Santo. Hello, Doctor.
Hello.
Oh,
Hello.
Doctor. Yes, Doctor. Are you ready with your presentation?
Yes, I'm ready.
So now I'm making you as a presenter. Please share your screen.
Okay. Let me just go. Perfect. So I'm also from IIASA, which is the International Institute for Applied Systems Analysis, and I usually use this this presentation format.
Yes, Doctor. Yeah, perfect. Please continue with your talk.
Okay, so today I'm going to talk about electric truck hydropower, a flexible solution for hydropower in mountainous regions. It's a proposal which I have submitted to Nature Energy. Nature Energy unfortunately did not accept. So now it's under review by the Energy Journal, Elsevier. And the proposal is to find a new solution for hydropower in mountainous regions because it's very highly capital intensive. The construction of tunnels, high dams, and the requirements of large reservoirs to regulate the flow of the river so that you have always a constant flow of water. And also there's no much innovation in hydropower. The turbines that they use today, they were created in 1902, 1930s, 1920s. So it has been a long time without so much innovation in hydropower. So now is a proposal for innovation. The idea is to use trucks, electric trucks with batteries. So the idea is to give a little charge for electric truck so that it has enough energy to go up a mountain with an empty container, catch a full container which is filled up by streams in the mountain, and then drive down the mountain, generating turning the potential energy in the water into chemical energy in the battery. The advantage of this technology is that, for example, you can use the same trucks that you use for transportation, transporting goods, and you can move the truck to to locations where you have ice melting, where you have rains, where the flow of the river is high. They don't need large catchment areas. They can operate with very small streams, and the containers, you don't need the dam. So the containers are the storage devices which can fill up according to the flow of the river, so that you don't have such a large impact on the river flow. So it's very flexible, very modular, and this paper tries to estimate the potential for the technology. So the idea for example, a truck driver that doesn't have so much goods to deliver, or it's driving down a mountain, he can fill up the containers with water and then charge the battery, so that he can keep going without having to stop in a petrol station to charge. But what I have in mind is to have autonomous trucks, so that the operational costs they reduce significantly. So the idea is to have these kind of skates under the container, driving the water around down the mountain, generating hydropower. And of course, if there is no rain, if there is no hydropower potential, then it can deliver goods also. So the methodology in the paper estimates the energy efficiency of the system, the cost for energy truck hydropower. It collects data for running a world potential estimation for the technology. These are the main technology, these are the main equations, which is energy equal to mass times height, difference of the energy potential equation, minus the energy losses by vehicles, which is the rolling resistance and the friction with air, which are the main losses. The data I used was topography, which is very important. So we're to see where the mountains are. Road infrastructure, so we assume that we don't have to build any roads, we just use the existing roads. So this grid has very good data. And runoff data. Runoff data is an estimate for the precipitation, sorry, not the precipitation, the amount of water that flows in from one grid cell to another grid cell, and eventually gathers into a large lake. But given that we're now looking into large rivers, we use runoff data just to catch a very small amount of water from a small section. And we normalize everything to 5 arc minutes, which is around 8 by 8 kilometers distance. So this is the topographic data. This is the surface runoff. You can see that you have a lot of runoff in the mountains. Mountains are usually locations where you have most rivers start from, most precipitation happens, and during the night you have a lot of moisture content turning into water also. And then you have road infrastructure from this grid database. And for the road infrastructure, we have to assume a road slope. So the most important parameter for this technology is the slope. So if this slope is very small, then the technology doesn't work. So this slope has to be very high. In these tall, high mountains, the slope is usually 10%, which is, for example, you have 10 kilometers horizontal and then 1 kilometer vertical. But we assume that it can go up to 15. The theoretical slope is just seen from one grid cell to the other grid cell, but of course you cannot build a straight road. It has to be a curved road, and you have to have a given slope. I took data from a reference which is from Alibaba actually. So Alibaba is very good with giving description of their equipment and costs. So for the cost estimation for this project, I use an existing truck. So these are the data. I'm not going to go into detail into all of them, but they're very good. I actually, this paper is already published as a preprint, and it's in my ResearchGate. So if you want to read the paper, it's there already, and you can see all the details there. So comparing different slopes at different speeds, you have that, so the ideal speed, and then for each slope and ideal speed, these are the best speeds for each slope. So is the cheapest. These ones we reject because it's too high, the slope. Electric trucks, they have a very high power capacity, so they can go up, for example, a 25% slope. But of course, we're talking about high mountains, there will be a lot of ice. Then if it's the icy roads, that's not possible. So that's why we fixed to 15. 15 is the maximum road slope. And the truck speed, the ideal truck speed would be 22.6 kilometers per hour. But this is for the best efficiency. Of course, if we're looking into costs, we increase the speed because of the investment. You don't want to pay a truck to drive 22 kilometers per hour. So at different truck velocities and different slopes, we have different efficiencies. So the lower the velocity, the higher the efficiency, the higher the slope, the higher the efficiency. So the overall system efficiency is around 60%. And this is the taking into account the roads, infrastructure, and the theoretical 15% slope. That's the result that we have. So in our estimate, we estimate the maximum road slope of 12 actually in the results. So the costs for electric truck hydropower, we have that if we have a slope of 5%, then the costs go around $100 per megawatt hour, which is quite low. And when it goes to 15% slope, the costs go down to $20 US per megawatt hour. 20. So if you generate electricity in the US with natural gas, you get a price of around $15 per megawatt hour. So we're comparing this technology with natural gas in the US. So it's competitive now. So if you want to make some money, buy a truck and start generating hydropower. There's an option today. Of course, according to the estimates of this study. Minimum electric truck hydropower per region. So this is the costs for different locations. For example, the best locations are the Andes, which it's in the tropics, so there is a lot of water. Also, the Himalayas has a lot of water and has a lot of high slope roads. The rest of the world, there are also high potential at different locations. This is the costs estimated. This is the potential, so how much hydropower you can generate. Of course, it varies a lot with the amount of water available also. So this, for example, in the Andes, you have areas with up to 10 terawatts hour per year that you can generate of hydropower. So each of these one arc grid shows the potential in each arc grid. Of course, you would need 500 trucks to generate 1 terawatt hour. So, but it's modular, so it's convenient. You can tailor it for your energy needs. So this is the capacity curve. the continent with the most hydropower, electric truck hydropower potential is the countryside. The continent is Asia, then is South America, then is Central America, Europe, Africa, North America, and Australia. And as a discussion, you have very large flexibility, hedge flexibility also, because hydropower you have one entrance point and one output. The electric truck hydropower can use the whole head flexibly. Capacity factor also is very high because of the flexibility. If it's not raining in one region, you go to the other region which starts to rain, so you can follow the rain, moves from one place to the other, doesn't need storage reservoirs. Seasonal storage doesn't need seasonal storage because the truck can just move to other places seasonally. It's applied mainly for small streams. Of course, if you have a large river, it doesn't make any sense to build a lot of electric trucks. You build a hydropower plant, right? So you also have this option. The lifetime is small, is 3 to 10 years, depending on the quality of your electric vehicle. But even with this low lifetime, the costs are smaller, almost half of hydropower. So levelized cost of hydropower varies from 50 to $200 per megawatt hour. Electric truck hydropower from 30 to 100. Another option is, for example, if you have a very high mountain and you also want to freeze the water and bring it down as ice, and then generate hydropower with the ice, but you also can use it for cooling under the mountain. Then this is very interesting in India, for example. India has very high mountains in the Himalayas, and you have very hot weather under the mountains. So you can combine cooling with hydropower. So as a conclusion, we have innovative, flexible hydropower generation alternative. Levelized cost, very low. Electricity generation, it's 1.2 petawatt hour, which is equivalent to 4% of global energy consumption in 2015. So there's a reasonable potential. And the countries with the highest potential is Asia, the continents, Asia and South America. Thank you.
Thank you, Dr. your presence and presentation. Is anyone having any questions? So I hope no questions. Thank you once again, Doctor.
Thank you.
Let's move on to the next presentation by Dr. Mengstu A. Chambri, Addis Ababa Science and Technology University, Ethiopia. Hello, Doctor. Are you ready with your presentation?
Hello, Mr. Chairman and respected presenters and participants. Can you hear me?
Yes, we can hear you. Now I'm making you as a presenter. Please share your screen.
Okay, I will share my presentation. Can you see it?
Yes, Doctor. Please continue with your talk.
Thank you very much. I will start my presentation. I am Mengstu Addis from Ethiopia, Addis Ababa Science and Technology University. I am a PhD candidate, and my paper is entitled as Urban Flood Management through Urban Land Use Optimization using the lead technology, or that is low impact development technologies. So, okay, my presentation outlines are as follows. I have an introduction part and the background, and some literature reviews, the objective, methodology, results, discussion, and finally conclusion part. As an introduction, nowadays, the impact of the climate change and the rapid urban sprawl is leading to the frequent flood events, especially for those urban areas are becoming affected as a result of intensive rainfall, short rainfall duration, and intensive rainfalls that are resulted from the climate change impacts. In my study area, there are more than 30% decadal urban growth rates, which we can imagine that how much it is a rapid urbanization. And as a result, studies and some reports indicate that more than 120,000 houses are vulnerable to flooding. And due to this, there are many loss of life, economy, environmental damage. These are all resulted due to aged and inadequate drainage facilities, urban drainage facilities, which are old and or inadequate. And currently, there are high global focuses of using climate adaptive, resilient, and sustainable urban storm management practices. So why I have selected using the low impact development methods. So this map shows that the Addis Ababa city in Ethiopia, Addis Ababa city is located in Ethiopia, which is the main head office of the African Union and capital city of Ethiopia. So how much there is a very rapid urban growth, as you see that in the upper part, the orange pointers indicate that urbanization is from 1986 to 2011, how much it is rapidly urbanized, and the bottom also shows the red ones are showing that the urban sprawl, the speed of urban growth. So as a result of this, in fact, there are observed the flood events mostly in each summer season, or that is rainy seasons. Observing such type of flood events become very frequent. Yeah, if these are how much the buildings are affected by the flood, and those road transportation facilities are also affected by flood events. And this shows also this is the riverine flood, and those areas and house residential areas are highly affected, and almost about 9 people have died in the last summer season of Ethiopian summer season, the last August. Yeah. So how much the people are suffering the flood events, even though it becomes difficult to walk on the walkways, and it is also difficult for vehicles to transport, and resulting to transport disruption due to this frequent flood phenomena. Yeah? How much the vehicles are, and how much the people are jumping from place to place to pass this flood events. These all are the as introduction, how much the flooding phenomena becomes a serious issue in developing countries. So my objective is to reduce the urban flood magnitudes using various low impact development scenarios and assessing the performance of the lead measures, and also analyzing the impact of rainfall patterns as a result of climate change on the lead management scenarios. I have selected the four lead scenarios. The first one is no application of lead scenario. The second one is infiltration-based lead practice, and lead method based on the water storage, and the combination techniques. This is my study area where Addis Ababa is located from Ethiopia, and my study specific area. So lead is simply, it is very decentralized, ecological based, and environmental adaptive. The urban storm management practices is most common nowadays. It uses the integration of these structural methods and non-structural methods. So it's a combination of the storage, increasing the infiltration, and storing the peak runoff. So by integrating these practices, it has very multiple advantages, and there are models, including the stormwater management model, includes this lead scenarios. It uses by integrating the hard engineering, the structural measure, with the soft engineering, that's non-structural measures. The overall advantage of the lead is reducing the flood magnitudes. It improves water quality on urban areas, and it will increase the groundwater recharge rate. And I have used the storm water management model, and have used my catchment in subdivision of about 34 sub-catchments in the total layout drainage systems. And the proposed lead techniques are introduced for each sub-catchment based on the land use and the catchment conditions. Yeah, my specific catchments are mostly residential, and there are also mixed use areas. So I have used based on the availability of the space and the catchment condition. Most of those residential areas, I have used storage, that is rain barrels, and on those mixed use and the communals, such as the condominium house or multi-use buildings, I have used urban spaces for infiltration trenches and bioretention shapes. And I have used the most the climate scenario, which is worst climate scenario of RCP 4.5 in comparison with RCP 8.5, based on the literatures that have given the result values. And I have selected also 3 rainfall patterns. The first rainfall pattern is simply the normal storm distribution. That means increasing, then decreasing rainfall pattern. And the second is the increasing type of rainfall pattern. And the third is the decreasing type of the rainfall patterns. Yeah, as you see that the green one is, it is increasing, then decreasing, which is a normal pattern of rainfall events. And the blue one is, it is increasing rainfall trend type of rainfall pattern, and the red one is, it is the decreasing type of rainfall pattern. So lead scenarios I have discussed earlier. I think the 4 types of lead combinations. This is my sub-catchment. This is my sub-catchment area, and this one indicates the blue one, the white blue one indicates the rain barrels, and the green one bioretention, and this blue one shows this infiltration trends. So from the my catchment, there are built-up areas about 75% of the impervious, and parking lots. There are also green areas, and there are roads and the pavements. And bioretention cell covers 26.2 hectare. That means 39% of the covered area, and infiltration range about 27.9, and the rest in barns. So I have used all available spaces and the residential areas for lead scenarios. Then I have computed in combination of various rainfall patterns plus lead combinations. I have come up with the results. I have selected the rainfall duration, 3 rainfall duration types, the 10-minute intensive rainfall duration, 30 minutes rainfall duration, and 1 hour rainfall durations. These rainfall durations are mostly frequent flood events that leading to the flash flood events may happen as a result of the climate change. Yeah? And the data starting from 10 minutes to 1 hour are collected from the meteorological stations, and using the frequency analysis Gambles method of flood frequency, I have estimated the flood events using the swim model. So the first result shows that the effect of lead combinations on 10-minute rainfall duration shows that about 76.4% of peak reduction, peak runoff reduction. And the only rain barrels can reduce 35% of the peak rainfall, and the combination of bioretention cells and infiltration ranges can reduce about 48.5%. This shows that how much the peak runoff can be reduced using those lead scenarios. This is shows that the blue one shows that the lead combination can reduce in relation with relative to the no lead scenarios. Yeah. So how much they are effective, and the second result is for 20 minutes. This is for using 30 minutes rainfall duration. This is also effective, and this 30 minutes rainfall duration also about 71% of peak runoff can be reduced using the combination of lead scenarios, both the storage and infiltration methods. So 46 and 7% using the storage, lead infiltration, and lead combination techniques. So this is how much it shows that in figures how much the low impact development scenarios will reduce the peak runoff. And this is the effect of the lead scenarios on 1 hour rainfall duration. Relatively, its magnitude of peak runoff reduction is relatively less than 10 minutes and 30 minutes rainfall durations, but in 1 hour duration also, the methods, the techniques have also significant reduction factors that can show up to 70% of peak runoff reduction. Is that is the combination techniques of these scenarios on all rainfall patterns of pattern 1, pattern 2, and the rainfall pattern 3. So relating to the climate change, the worst climate change can increase the runoff magnitude. So compared to no climate change scenarios, it shows that a very significant impact of runoff reduction. The other thing I have selected the discussion board is impact of rainfall patterns on peak runoff magnitudes. So compared to rainfall pattern 1, the 10 minutes rainfall event have the increased rate of about 28.1% for rainfall patterns TS2 and 6.4% for rainfall pattern TS3. That means that mostly rainfall pattern when the peak rainfall magnitude is at the last time duration, it shows that most of the initial obstructions and depression storage will be filled with less intensive rainfall, and the last intensive rainfall may lead to the significant runoff magnitudes. So that shows that significant increase of runoff relative to the normal rainfall trends. So how much that the climate change may affect the rainfall trends, then if initially the antecedent moisture condition is dry, so it will be filled with less intensive rainfall, and the final intensive rainfall will lead to the high flood magnitudes. So relative to the other literatures that have done with the same methodologies, so my result is relatively high runoff magnitude efficiency. So finally, as a conclusion, the lead has a high performance on peak runoff reduction if it is effectively applied. If it is effectively applied on the available spaces for all residential and other land use types based on the combination scenarios. If there is a very restricted space, use bioretention cells and infiltration trenches and biofuels and so on. These restricted areas can use also rain barrels for peak runoff reduction as storage. When the peak runoff is reduced, this runoff can be released safely. So I would recommend that those all developing nations and urban areas can effectively use lead scenarios by incorporating on their urban policies, designs, and construction manuals. Thank you. Finally, how much this significantly reduces the runoff magnitude shows that the completion of the lead scenarios.
Thank you, Doctor, for your presence and presentation. Is anyone having any questions? I hope no questions. Thank you once again, Doctor.
Okay, thank you. Thank you very much.
Let's move on to the next presentation by Dr. Ngenzen Muhoro, Mohammadi University of Rabat, Morocco. Hello, Doctor. Are you ready with your presentation? Can you hear me, Doctor? Doctor, can you hear me? Sorry, your voice is not audible to us. Sorry, doctor, we cannot hear you. Please click on the mic button. We cannot hear your voice. Please click on the mic button to unmute yourself, doctor. Sorry, doctor, we cannot hear your voice. Hello, Dr. Ngenji Buhoro. Can you hear me? Your voice is not audible to us. Could you please just log out and log in once again? Doctor, please click on the mic button. Hello, Dr. Ngenji Buhoro. Can you hear me? Sorry for the inconvenience. Let's wait for a few more minutes. Hello, doctor. Can you hear me? But your voice is not audible to everyone. Hello, doctor. Hello, doctor. Are you using any headset or any earphones? Sorry, we are not audible. Could you please remove your headset or earphones? Sorry, doctor. We cannot hear your voice. Could you please use any other earphones or any headset? Sorry, Dr. Nyanjibiharo, I think you have some technical issues. So I would like to announce Dr. Harry H. Fayek to present her presentation. We'll announce your talk after the lunch break. Sorry for the inconvenience.
Hey, Elena, can you hear me?
Yeah, I can hear you. Are you able to make your presentation now?
Yes, I can do it now.
Okay, then. So let's move on to the next presentation by Dr. Harry H. Fayek, Heliopolis University, Egypt. So, Doctor, I will make you the presenter now. Please continue.
Okay.
Please share your screen, Doctor. Yeah, we can able to see your screen, so make it full screen.
Okay, 1 second. Now, can you see it? Can you see my screen?
Yeah, perfect. Please continue with your talk.
Okay, so thank you for the organizers for hosting me in this webinar about environmental engineering and sustainable technologies. Today, I will be talking about secure and reliable operation of systems with 100% share of sustainable energy. I'm Hadi Habib. I'm lecturer in Faculty of Engineering at Heliopolis University in the Renewable Energy Program. In addition, I'm the chairman of the IEEE Industrial Electronics Society Egypt chapter. I would like to start my presentation with this image, which you can consider the dream of all the people who are working in the energy sector, either from research or from industry or even the users point of views, where you can consider that all the world one day we are dreaming to get its energy only from sustainable energy resources such as sun, wind, tidal, bioenergy or biomass, and so on. Actually, this is the big dream that we are working now in the energy to achieve it. In addition to that, we are trying to make use of all the facilities that we are in now and the technology to reach our aim, our goal. And before starting our presentation, I would like to ask a question. Is 100% renewable energy something possible? Is the dream of the previous image possible to be achieved or not? Well, before answering this question by yes or no, we have to check some numbers of the penetration level of renewable energy in electricity generation in some countries. Iceland produces all its electricity from renewable energy generators. Norway has 98% penetration level of renewable energies. Costa Rica is producing more than 99.6% of its electricity from renewable energy power plants. So you can say that Costa Rica is fully producing its energy from renewable energy resources. Brazil and Kenya are achieving 70% of their electricity from renewable energy resources. And worldwide, the penetration level of renewable energy is 23%, which is now a good number. So as you see, there are countries already achieving full production of electricity from renewable energy resources. So the answer of the question is yes, because that's something which is already achieved in some countries. Then we come to another question: why 100% renewable energy? What is the benefit from that? Number one, because first of all, as we mentioned, that's something that we can do. There are already countries now working with 100% or near 100% renewable energy, so it's something technically and economically feasible. Number two, this scenario will save money because at the long run, the crude oil cost will be increasing while the renewable energy cost is in gradual decreasing. So in the future, renewable energy will be much cheaper than the crude oil, which is its cost is increasing day by day. Well, this scenario is also the 100% renewable energy will afford more jobs than the energy scenario now or in the previous decades. Number four, which I believe is the most important reason of turning to 100% renewable energy, is that 100% renewable energy will put us in the scenario to stay below 2 degrees of the temperature, which is one of the main reasons of the climate change crisis that we began to live now, and we will even live more in it in the future if we stayed in our consumption and our carbon dioxide emissions. And to achieve this plan, reaching 100% renewable energy, the world is planning to fully produce its energy from renewable energy resources by 2050. To achieve this means that in 2030, we should have achieved 42% of our energy production to be from renewable energy resources. This means that in 2050, to have fully energy production from renewable energy, that we are going to produce 23,000 gigawatt or even more from renewable energy power plants. Well, the scenario of 100% renewable energy will achieve 45.2 million jobs in comparison to 29.1 million jobs with the scenario of the current production of energy nowadays. Well, we can also say is that the reduction in carbon dioxide emission will reach even zero carbon dioxide emission in 2050. This could be achieved gradually, such that in 2030 you will achieve 96% of the carbon dioxide emission. 2040 we will achieve 39%. All these numbers are calculated in the reference of the carbon dioxide emission of 1990. So if this is the 100% renewable energy dream and the view of the world to achieve it in 2050, so what are the technologies that we are going to rely on to reach 100% renewable energy? Actually, we have the sun, which we can convert it to electric energy through PV and through concentrated solar power. We have the wind, and surely the wind turbine can convert it to electricity. We have the geothermal energy, which we can convert to thermal energy or electrical energy. We have the tidal and the waves, which we can convert it to electricity. We have also the biomass. The most three technologies that are growing fast to achieve the dream of 100% renewable energy are the PV, which comes in the first place now due to its less cost and due to the availability of the sun in many countries. As you can see how the PV installed capacity is increasing in the world year by year. Then in the second place, you can find the wind. And what is growing rapidly is now the biomass due to the dependence on the wastes, and the wastes never end of plants, animals, and human beings, and so on. So then we come to another question. What are the challenges to achieve 100% renewable energy? So what could be problems or issues that is difficult somehow to achieve 100% renewable? Number one is the uncertainty. because most of the renewable energy resources have a stochastic nature. For example, I'm not sure that in Egypt there will be enough wind in August to produce enough electricity to feed a load or something. So it's a little bit not easy to rely on the wind energy or the wind turbines. Number two, well, most of the renewable energy power plants depend on large tracts of land, which is usually needs spaces, but this is not a big problem in countries like Egypt or India, where you can find deserts and so on. Number three, the material or that you can manufacture the renewable energy systems from it are a little bit not easy to find and a little bit still expensive because it's not easy to convert it. Number four, the transportation of energy from one place to another this is still an issue from the logistics point of view. Number five, the economic cost is always an issue for anything new, and still some of the renewable energy systems is still new. So to face these challenges and to have 100% renewable energy campus or environment or country or whatever, you need to follow some rules or features. Number one, you should be energy efficient to a large extent. There is no need to operate anything which you can postpone using it now. Number two, the electricity to get it from renewable energy resources, it's much better to rely on more than one renewable energy generator. For example, have a hybrid system from PV and wind, from the PV and the fuel cell, PV and biogas, biodiesel and whatever. Number three, you have to ensure that everyone has access to this energy which is generated from sustainable energy resources. Number four, you have to consider the connection between different microgrids, let me say, or different places that are operating with 100% renewable energy in an off-grid basis. So we can help each other, we can exchange electricity with each other. This will even make the renewable energy much cheaper. Number five, and to make it fully reliable, to have 100% renewable energy, you need to depend on the new technologies of the smart grids, the control, and also you have to rely on the storage system, which plays the most important role in many renewable energy systems, such as PV systems, because there is no sun at night, wind energy systems, and so on. Well, we are working in many projects that's related to the 100% renewable energy in different scales. Some of them are in country power grid scale, and others are in microgrid scales. So the first project is operation of a region in Egypt, which is called the Upper Egypt region, with 100% renewable energy. And in addition to that, we are trying to maximize the penetration level of renewable energy in the Egyptian grid. Before I'm telling you how we are trying to control this, I would like to let you know a little bit about the Egyptian grid. Actually, Egyptian grid is consisting of 6 regions: Cairo region, Alexandria region, Canal region, Delta region, Middle Egypt region, and the Upper Egypt region. Well, we are going to focus a little bit on the Upper Egypt region for the reasons that you are going to tell you about it, and also the Canal grid zone. Well, Upper Egypt region. In Upper Egypt, first of all, you can find 2 things. You can find and that's something a little bit new, and the second thing that you are going to find is 1/3 of the monuments of the wallet, which is located in Upper Egypt. I will try to complete talking about the renewable energy because I'm not expert in the monuments and so on. So in Upper Egypt, you can find 2 hydropower stations. One of them is called the High Dam with 2.1 gigawatt installed capacity, and the other one is Aswan Dam with 0.55 gigawatt installed capacity. You cannot find in Egypt other dams besides those. So those are the only 2 dams in Egypt. The total installed capacity of both of them is 2.65 gigawatt. In addition to that, you can find also in Upper Egypt, in Aswan, the largest photovoltaic park without storage system with 1.8 gigawatt of PV. The 3 power stations are the only power stations located in Upper Egypt. This is for the Upper Egypt region. For Canal region, you can find thermal power station and also wind power stations. You can find Zafrana wind farm with 545 megawatt installed capacity and 580 megawatt installed capacity of Jabal Zayt wind farm. Those are 2 big wind farms. Zafrana was the largest wind farm worldwide in 1995 when it was constructed. Well, what we are going to do is we need to ensure 100% penetration level of renewables in Upper Egypt region and maximize the penetration level of renewable energy in the Egyptian grid. What we made is that we simulated the Egyptian grid in an accurate basis, and we verified our simulation with the control center of the Egyptian grid. And then we applied what we call it optimal power flow, such that we have 2 objectives. The first one is to minimize the total power losses. And the second one is to maximize the penetration level of renewable energy through minimizing the curtailed power of each renewable energy resources. Well, this is the equation of the first objective, which is the minimization of total power losses, and F2 for the second objective, which is the minimization of the curtailed power of each renewable energy farm or park. And we assumed that both objectives have the same importance. And this optimization process is subjected to some constraints, like the power flow equations, the limits of each generator, either it was from the renewable energy or from the thermal energy. Also, the constraints of the voltage are considered. In addition, the thermal limits of the transmission lines are also considered through mentioning the maximum capability of power that each transmission line or cable can carry. And we use the new techniques in optimization, like teaching and learning based optimization, which is a hybrid optimization process. And we apply this optimization in hourly basis, considering the change of the load hour by hour and the change of the availability of the radiation and wind speed, also hour by hour. And then we try to apply this optimization process, considering this real data, which represent a summer day in terms of hourly load, hourly radiation, and hourly wind speed. And we calculated the penetration level of renewables in Upper Egypt and the penetration level of renewable energy on the whole grid. And we found that applying these optimization techniques ensure 100% penetration level of renewable energy in Upper Egypt region for about 10 hours a day in summer, and ensure more than 15% of penetration level of renewable energy in the whole Egyptian grid, more than also 10 hours a day. And the power losses is reduced by applying this optimization process by 20%. We repeated the same operation in winter days, And you can find that in winter, the total demand reduced by 1/3 of the total load of the summer days. And we consider the real radiation and wind speeds in winter. And we found that in winter, Upper Egypt region can achieve 100% renewable energy through optimization all the hours of the day. So the whole day or the whole winter period is operating with 100% renewable energy in Upper Egypt. And we found that we can reach 20% or even more of penetration level of renewables in the whole Egyptian grid, 10 hours a day or even more. And we could achieve less power losses by 10% in winter. This was the first project. It was a grid scale project. Second project is a microgrid scale project. Is how to convert Heliopolis University, where I'm working in, to 100% renewable energy on grid community. So what we are going to do is that we are going to install PV systems such that we need the PV to generate amount of energy equivalent to our energy consumption in the whole year. So at the end of the day, you are not going to pay for electricity to the electricity company. This could happen by installing 200 kilowatt of PV system through the following steps. We first calculated the current demand and the future load prediction, and then we began to calculate the PV capacity, and we found it 200 kilowatts that can cover the total consumption of electricity in the university. We then selected the best locations to locate the PV microgrids. After that, we made the wiring and the mechanical connections of the system. Then we test the system, and now the system is operated and supervised by the university and the Ministry of Electricity. First of all, this was the demand in 2019 before COVID in Heliopolis University in terms of money and in terms of energy consumption in kilowatt hour. And this was in 2020, the demand after the COVID. And we found that it was reduced by more than 30% or something in COVID, because all the education is turned to be online. We tried to calculate the peak sun hours through the small PV stations that we have in the roof of Faculty of Engineering with 4.5 kilowatt installed capacity. Since 2013, we calculated from it the peak sun hours, and then we began the calculation, and we found that having 200 kilowatt PV system will be enough to cover our consumption, considering different scenarios of how the education is going to be after COVID-19. And we found that it will be partially online, and also the students will come to the university to attend the labs and so on. With the total cost of the project is near £1 million, and we calculated the payback, and we found that we are going to get back this money in 1.6 years by saving the money that we was paying for the electricity company when we were consuming our power from the Egyptian grid oil. And this was the places where we installed our PV in the roof of pharmacy and pharmacy faculty, and in the roof of physical therapy faculty, and in the roof of the main office. The third project was how to control bio and solar energy in agriculture community to achieve 100% renewable energy agriculture community. Well, the people of agriculture have a dream similar to the people of energy. They are dreaming to have 100% organic agriculture. So in this project, we try to merge our dreams with each other to achieve, both of us achieve our dreams. So we try to make use of the organic wastes of animals and planets in the farm. And from it, we can use it as an input for the biodiesel and the biogas. And then the biomanure that we are going to have it from biodiesel and the biogas, we are going to use it as composite for the organic farming. And then the cycle repeats itself again. So for renewable energy, we have the biodiesel, biogas, and we also have the sun, which we need to use it to convert it to electricity. So we try to use the PV and the CSP in this project, in addition to the energy storage, to ensure reliable operation. Actually, we have two farms, second farm, and the other farm is in Mizan farm, and we considered having those systems in each of them, and we connected the two farms with each other through a line, and we tried to use new control schemes and the new optimization techniques to optimally operate the biogas and the biodiesel, in addition to the storage systems, to cover the change in the demand and in the load. As you can see, this is the change in the demand and the change in solar power. We cannot control those two, but what we can control is the biogas and the biodiesel, and also the storage, to cover the change in the demand and in the solar energy, and to ensure that we measured the frequency, and we found zero frequency deviation, which means that all the power needed is covered by the bioenergy and the storage. We applied this practically in second farm, and this some photos from second farm and in Mizan farm. They are related to the same owner, so they are easily interconnected to each other, and we achieved 100% renewable energy in those two farms. The first project is achieving 100% renewable energy in marine communities, some islands which are isolated from the grid in the middle of a sea or an ocean, and we relied only on wave system, offshore wind, and tidal systems to feed those islands. We simulated each system, the wave system, the offshore wind, and the tidal system, and we use the integrators to control the tidal turbines to cover the change in the demand and the change in the waves. And we also applied optimization techniques to optimally operate the controllers, and we found that we achieved fully covering of the change in demand and the change in the wave energy by controlling the tidal turbine and the wind turbine. And at this point, we achieved zero frequency, which was an indicator that we succeeded in covering the change in consumption in Fiji. We applied our study in Fiji Island. The fifth project is control of voltage in 100% renewable energy power grid, back again to the power grid scale. This was a simulated project. We assumed that we have a fully renewable energy power grid with very high penetration level of wind and PV systems, as shown in this table and in this single line diagram. And we assumed that we are connecting those renewable energy power plants according to the Norwegian grid code for integrating wind energy systems and the German grid code for integrating PV systems. And we used a new voltage control scheme to control the voltage of the power grid by controlling something called reactive power, which we can produce from the PV and wind. And this was a little bit new at that time, because we usually produce active power only from wind and PV, but the new was that we produced also reactive power to control the voltage through this control circuit, through a PID controller, current integrator, and voltage integrator, in addition to the inverter. This also happened through using novel measurement devices in terms of phasor measurement units, so we can measure the magnitude and the angle, and to make it not too much expensive, we try to minimize the number of the phasor measurement units, so we selected their optimal locations, and we selected which load bus that we are going to apply this control technique in it. And if we controlled the voltage of it in the right way, then we are controlling the voltage of the whole grid. And we subjected the system to many circumstances. One of them was the outage of 1/4 of the wind farm capacity located at busbar number 1, and with optimization to achieve minimum power losses, we need to have bus 5 with 0.994 per unit voltage, and we achieved through our control circuit. And we then calculated two things: the power losses in megawatt and the voltage deviation index. As much as they are low, as much as we are succeeded, and we found that with our new technique we achieve better results, as you can see from numbers, than if we couldn't achieve it without applying these new techniques. The sixth project and the final one is floating PV in Egypt. As I mentioned in the first project, we have two dams in Egypt, Aswan Dam and the High Dam. What we studied is how to maximize the benefit from those two dams by putting PV on it, this type of PV called floating PV system, and we found that this will improve the efficiency of both the dam and the PV. For the PV, because the water is cooling the PV, and for the dam, because we are avoiding the evaporation of water from the dam in the morning when it's subjected to sun. And we calculated many things, and we found that we achieved better operation of the dam and of the PV through this hybridization. We could achieve annual yield of 10 gigawatt-hour power from the FPV and 0.1 MCM of water saved from the evaporation losses. And we avoided 44,000 tons of carbon dioxide emission, with an annual increase of 11 gigawatt-hour of hydro power from the two dams. So this could be a good solution to achieve 100% renewable energy if you have dams or water, through applying the floating PV concept. At the end, to conclude this talk, 100% renewable energy is something applicable. It's already in the ground in some countries. Statistics and the world is dreaming that in 2050 we could achieve 100% renewable energy. 100% renewable energy cannot be done only by energy engineers and energy researchers, experts, and so on, but we need other people from different disciplines like agriculture, industry, and so on. Smart metering, smart controllers, new techniques will also be a very good point to reach secure 100% renewable energy. Applications also shows that we have two options to ensure secure operation and reliable operation of 100% renewable energy, either to have hybrid systems or to have storage with a single system, for example, PV and storage, or PV and hydro, for example. So in this situation, you can achieve 100% renewable energy safely. This was the references that I used to prepare this presentation. That's some of my research, which is related to each project that I talked about it. At the end, I would like to thank you very much, and I'm welcoming any questions. Thank you.
Thank you for your presentation, Doctor. Is anyone having any questions?
I just want to congratulations to Mr. Hadi for that great presentation and very brief data about all the aspects of renewable energy.
Okay, excuse me, I didn't hear the question well.
I'm Dr. Alexander Rudnik Milanovic from Serbia.
Welcome.
Congratulations on a great presentation and very deep detail about every aspect of renewable energy efficiency in Egypt. I am very impressed about the things going on very well in Egypt, and thanks to the researcher just you are. Yes.
Thank you very much. Thank you very much for your kind words. It's my pleasure to hear such words from you. And hopefully we can cooperate in something if you are interested.
Yes, we will be in touch. We can exchange our emails so we can cooperate, of course. I'm an architect PhD, so I'm really thankful to be here and to meet some new researcher. Yes.
More than welcome. This is my email. I think you are seeing it in the screen, saadihabib@hotmail.com. You are more than welcome for any kind of.
Thank you, Khadi.
Thank you. So, as per the schedule, let's take lunch break from now, and we'll be back within 30 minutes. Please stay connected.
Thank you.
Hello, everyone. Can you hear me?
Hello.
Yeah, hi. So let's continue
Hi,
with our
Helena.
next presentations.
Okay.
Yeah, by Dr. Negus Brujo Muhammad B, University of Rabat, Morocco. Hello, doctor. Are you ready with your presentation?
Okay, I'm ready.
Perfect.
Now now is okay.
Yeah, yeah. Now I'm making you as a presenter. Please share your screen.
Is it okay
Doctor,
now?
yeah, please share your screen. Yeah, it's visible. So make it as a
Now
full
it's okay.
screen. Yeah.
Okay.
Yes, doctor, please continue with your talk.
I can begin.
Yeah, please continue, doctor.
Thank you very much. My name is Genzo Pieklaver from University Mohammed V University of Rabat. Here I want to present results from a part of my PhD thesis about applications of morphometric analysis and the TSN method for hydrological study using the GIS technique used in a watershed in Burundi, northwestern of Burundi. For introduction of this subject, it is that is an important aspect of characterization of watershed, and the watershed analysis based on morphometric analysis is very important for watershed planning. It gives an idea about the basic characteristics like topography, slope, soil conditions, runoff characteristics, and surface water potential, etc. In this study, in the study area, the geographical information system GIS using digital elevation model with 10 meter of resolution were convenient tools. Those tools will be used for delineation of the Panda watershed, the study area and
Sorry
its
for the inconvenience, doctor.
sub-watersheds.
Sorry for the
Sorry?
inconvenience. Could you please make it as a next slide? Like we can able to see just one slide.
You don't see a landslide?
Yeah, you need to click on the next slide to present your presentation.
Like this?
Yeah, just click on the next slide, like second screen to change the slide. Yeah, perfect.
But now it's okay.
Yeah, it's okay.
Okay, to the study area, the location of my study area is it's located in northwestern Burundi, and here we can see map of Africa and where is the country. Burundi is a small country in East Africa, and the the study area is located in northwestern Burundi, and it's extend over to geographically different zone. Here, the alluvial zone here, and the foothill zones. Its upstream is close to dividing of the Congo Nile ridge at an altitude of 20,670 meter, calculated from the M, while its outlet in this river Rusizi is at 777 meter. The total areas of these study areas is 451 square kilometer, while the upper in the foothills basin is 240 square kilometer, and the the alluvial plain basin is 210 10 square kilometer. About geology, also the geology of the study area consists of a Precambrian and the Cenozoic units, and the Cenozoic area consists of Holocene age and middle Pleistocene in the alluvial plain basin, but Precambrian, constituted by magmatic and metamorphic rocks, are localized in foothills zone with many faults. Here you can see that the zone is very tectonized. About parameter estimation method, we used it to delineate to have characteristic of this basin. We use different parameter like surface of the study area. That is the method we use, direct measurement after delineation with GIS software. Perimeter also is direct measurement. We calculate from surface and perimeter the length, axial length, with this formula, and also from surface and length, we calculate also compactness factor, which is ratio of the perimeter of the basin to that of the same area. We calculate also clarity ratio, elongation ratio with formulas, form factor, also stream order, bifurcation ratio, stream length, drainage density, and the stream frequency. We will explain in the result of for all those parameters. In the second part of result, we use the TSN method to estimate average volume of water that falls on a base, and we used this formula below. For the results, and first is geometry and the shape parameters. And the shape of the catchment area, our watershed, influence the characteristics and a given rainfall, and we have all watershed, Banda watershed, wall basin with his surface, and in previous landslide we said that we show that we divided our watershed into sub-basin, upper basin in the foothills, and alluvial plain watershed. Those is their surfaces, perimeters, and the length, width, compactness factors, which is for the whole basin is 1.9, and for the upper basin is 1.72, and the alluvial plain is 1.775. Security ratio also is shown here, and the elongation also, and form factor. How we can explain those factors to characterize geometry and the watershed shape? We can see that the security ratio of our watershed is vary from 0.26 to 0.32, and the form factor also can't reach 0.79 for the circle basin. Elongation also is lower than zero. The value for circle basin also length is largely greater than width. With this situation indicate that the basin is elongated watershed. So this situation means that the basin is favorable to low peak flows for the same rainfall due to the longer time it takes for the water to reach the outlets. And is about drainage network parameters. With them, we extract automatically with drainage network, which is we have five orders in this basin, and we can see here that blue is the main, the red is the smallest, and you can explain this that in this table, the drainage network parameter in this table, that we can see first column is stream order, first to fifth, number of stream, length of stream, and the bifurcation ratio. We can see that the Mpanda watershed has a higher number of first order channel with a number of 247 in a total of about 500, which represents 50%, more than 50% of the whole drainage network. In this tested area, it can be seen that most of the drainage network is largely concentrated in the upper basin, the foothills, compared to the alluvial plain basin. A high number of streams indicate that the upper basin is lesser permeability and infiltration. Length of stream is high in case of the first order stream, and decrease with increase of the stream order, except on the fifth order stream, whose length is higher than the total length of the fourth other stream. This high variation also for RB bifurcation ratio is related to the heterogeneity of the basin geometry and the lithology. The highest bifurcation ratio we find is 7.6, and it's found between the third and the fourth order that indicated in this area corresponding to highest overland flow and discharge attributed to high less permeable rock formation associated with high slope configurations. And about drainage density and the stream frequency of the study area, we have for the whole basin drainage density of 1.23, and for upper watershed is about 1, and almost 1 alluvial plain watershed is 1.23, and for stream frequency also it's shown in this column of this table. How we can say that the drainage density is moderate if we see these values, and indicate that the watershed has permeable subsurface material, good vegetation cover in the foothills, upper watershed, that is can cause more infiltration of water and recharging groundwater aquifers in alluvial plain fall. Those factor for value in alluvial plain. The upper basin has low stream frequency, though this while the alluvial plain watershed present a relatively high stream frequency. Those value of stream frequency reflects that the basin has good vegetation, high infiltration capacity, and the later peak discharge on low runoff rate. We can deduce that stream frequency show positive correlation with drainage density, and it means that the runoff is slower and the flooding is less likely in basin with a low to moderate drainage density and stream frequency. And the second part of results is the spatial rainfall distribution using TSN method. And the TSN method in this area, this basin, we have five hydroclimatological station which record precipitation and temperature, and we consider only precipitation rainfall, and the area of each polygon is corresponding to the rainfall of a period of 20 years since 1995 to 2015, and they are shown in this table. We can see all this, and the figure in this map, we can see different colors related to different stations. We can see that stations Musigat, and this is recorded a lot of record is the main stations, like which records a big quantity of rainfall, and you can see this station is in foothills in the upper basin, and this is in alluvial plain. And we said that our study area is located in two geographical regions, and if we estimated average rainfall, we find that is small values compared to the rainfall recorded in the foothills. So we divided our method, we applicated our method to the two different sub-basins. In order to understand the that falls in each area, it is necessary to perform separate calculation between the alluvial plain, which receives less rainfall, and the foothills, which receive a lot of rainfall. Those rainfalls are presented with these two maps. For the first maps, we can see that the upper basin in foothills, average precipitation rainfall is 1,696 millimeter. Then if we use the same method in alluvial plain, we have our average rainfall like equals to 958 millimeter. We can deduce that the upper sub-basin receive almost twice the rainfall recorded in the alluvial plain basin. It is the rainfall in the foothills upper basin that feeds the river flow upstream of the Panda's outlet here, in this point, into the plain, and it's also responsible for infiltration that recharge the water table, which enriches in turn during the dry periods. And about conclusions, this study has shown that GIS software is useful for the analysis of geomorphometric aspects of drainage, watershed, and spatial rainfall distribution. For geometry analyzed showed that the Panda watershed and its sub-watersheds have elongated shapes. If we consider those factors, compactness factor, length, width, circularity ratio, form factor also, which indicated longer concentration time during rainfall and cannot develop peak flood at the watershed outlets. We can also conclude that the Panda watershed is a fifth order basin. The first order stream dominates the basin more than 50%, and the development of the stream segment in the study area is affected by rainfall and groundwater discharge. The mean bifurcation ratio indicates that geological heterogeneity in the upper basin, higher permeability, and lesser structural control. The drainage density of the Mpanda drainage basin is moderate and indicates that the watershed has permeable subsurface material, good vegetation cover in upper basin, causing more infiltration of water and recharging groundwater aquifers in alluvial plain watershed. And after we can conclude that the stream frequency show positive correlation with drainage density. It means that the runoff is slower and flooding is less likely in basin with a low to moderate drainage density and stream length. For the average rainfall calculated using the TSN method for a period of 20 years over the entire Mpanda River watershed is 1,341 millimeter. This average precipitation over the 20 years concerned appears to be low if we consider the precipitation recorded by the stations in the foothills. This is why we have subdivided the Mpanda watershed into sub-basins, and we conclude that the upper basin receives almost twice the rainfall recorded in the alluvial plain basin. So, the result of the study area can can serve as a baseline for water resource manager and agricultural manager, especially in the plan for water management of the Mpanda River in order to plan the irrigation of rice and the food crops during the dry season. The upper basin should be managed to reduce runoff and promote infiltration that recharge the aquifer, feeding the base flow of the main river, especially during the dry season. Thank you for your attention.
Thank you, Doctor, for your presence and presentation. Is anyone having any question? I hope no questions. Let's move on to the next presentation by Farah Jamili,
Thank you.
University of South Tunisia. Hello, Doctor. Are you ready with your presentation?
Hello. Yes, I'm ready. I'm going to.
Yeah, now I'm making you as a presenter. Please share your screen.
Okay, so give me the right, please. Okay. Okay.
Yeah.
Okay. Can you
we
see
can
my
able to see your
presentation?
screen. Yes,
Okay,
perfect.
thank you.
Please continue to talk.
Okay. So, hello everyone, glad to meet you on this webinar. Today I'm going to talk about data fusion based on big data techniques in intrusion detection context. If you have any questions, I will try to answer them afterwards. So, to start with, I'm going to introduce myself. So my name is Farah Jamili. I'm from Tunisia. I work as an assistant professor at University of Sousse. I have a PhD and engineer degrees in computer science. I have extensive experience as a researcher in artificial intelligence, big data analytics, cloud computing, with special focus on intrusion detection contexts. Okay, so let's get back on topic. Nowadays, we are going through the most important changes in communication technologies. The most important communication technologies are social media, SMS, text messaging, email marketing, direct email, blogging, voice calling, video chat, video marketing, live web chat, virtual reality. These technologies produce 2.5 of data each day, and this number is going to accelerating with the growth of Internet of Things. Cybersecurity experts said that damage related to cyber attacks is projected to hit $6 trillion annually by 2022. So let's have a look to okay, so let's have a look to damages, last year's biggest damages, and how much did they cost. So Equifax, Yahoo, and Uber have lost hundreds of millions of dollars due to cyber attacks and data breaches. Among these attacks are denial of service, distributed denial of service, network scans, bot scans, and botnets. And with the massive data being generated daily, restoration becomes more and more complicated. So from there arise some issues and challenges. The first issue is how to store massive data. This issue has to do with big data collection, storage, and cleaning. The second issue is how to process diverse and heterogeneous data. This question has to do with the big data fusion and processing. And the third issue is how to achieve accurate intrusion detection. This issue has to do with artificial intelligence and machine learning. So to answer to these questions, our research is based on four main pillars. The first pillar is cybersecurity, which include security concepts and mechanisms. The second pillar is cloud computing, which includes storage services. The third pillar is big data, which includes big data analytics tools. And the fourth pillar is artificial intelligence, which includes AI technique for machine learning and decision making. So let's let's start with the first pillar, which is cybersecurity. Cybersecurity is the application of technologies, processes, and controls to protect systems, networks, program devices, and data from cyber attacks. It aims to reduce the risk of cyber attacks and protect against the unauthorized exploitation of systems, network, and technologies. Technologies consists of firewall and VPN, access control, and intrusion detection. In our contribution, we are going to focus on intrusion detection technologies. So what is an intrusion detection system? An IDS is a device or software application that monitors a network for malicious activity or policy violations. An intrusion detection system is characterized by 6 main characteristics. The first one is the intrusion detection approach. It can be anomaly-based or signature-based. Anomaly-based compares traffic to a predefined model, also called behavior-based detection. And signature-based approach is where signatures are defined to look for characteristics within network traffic, like antivirus. The second characteristic of intrusion detection system is protected system. It can be either host-based intrusion detection system, network intrusion detection system, or hybrid intrusion detection system. The next characteristic is structure. It can be centralized system or distributed system. The fourth characteristic is data source. It can be audit trail, network packets, or system state analysis. The next characteristics is behavior after an attack. It can be active or passive. And the last characteristic has to do with analysis time. It can be on-the-fly processing or interval-based IDS. So here we introduce the second pillar, which is cloud computing. So what is cloud computing? It is the delivery of different services through the internet. These resources include tools and applications like data storage, servers, databases, networking, and software. It has different delivery models. It can be infrastructure as a service, platform as a service, or software as a service. It has different deployments. It can be public, private, community, and hybrid cloud. It offers different services. It processes, stores, and manages data. So it requires minimal management efforts, offers rapid services, and with low costs. The next pillar is big data. What is big data? It's when data can't be processed or stored in a single machine or a single program, then it is called big data. Big data is characterized with 4 V's. The first V is the scale of its volume. It has to do with the scale of data. The second V is variety. It has to do with the forms of data. The third V is velocity. It has to do with the analysis of data flow. And the last V is veracity, which has to do with uncertainty of data. Next pillar, the fourth pillar, is artificial intelligence. Artificial intelligence is the ability of a system, such as a computer, hardware, software, or another devices, to acquire and apply knowledge and skills. Artificial intelligence is composed of machine learning, which consists in deep learning and predictive analytics. The second part of artificial intelligence is natural language processing, which consists in translation, classification, and clustering, and information extraction. The next part is speech, either it is speech to text or text to speech. The next part is expert systems, then planning, scheduling, and optimization. Robotics is also part of artificial intelligence, and the last part is vision, which consists in image recognition and in vision. In our contribution, we are focusing on machine learning as part of artificial intelligence. So what is machine learning? Machine learning is an application of artificial intelligence that provides systems the ability to automatically learn and improve from experience without being explicitly programmed. So machine learning algorithm can be supervised, unsupervised, or reinforcement algorithms. Supervised algorithm is good for problems where each input data point is labeled or belongs to a category. So supervised learning is trained on a labeled data set. And supervised learning is good for problems where each data is not labeled or does not belong to a category. These algorithms are good for clustering, grouping complex data into classes. So this type of machine learning is trained on an unlabeled data set. And the third type of machine learning is reinforcement. It is good for problems where future actions are based on outcome of current responses and next actions are required to be forecasted. This type of machine learning consists in to learn through trial and error from interaction with the environment. There is no data set. Example, learning to play a game. So here is an example of a typical ML machine learning process. So given a set of raw data provided by data providers, the first step is pre-processing data using data processing tools in order to obtain structured data. The next step is to apply a machine learning algorithm and to iterate this step in order to obtain a candidate model in order to obtain the best model. And this model, the selected model, will be applied in real-world applications. So here, the popular machine learning algorithm for supervised learning for classification. We have support vector machine, discriminant analysis, naive Bayes, nearest neighbor neural networks. These are examples of algorithm for classification. For regression, we have linear regression algorithm, SPR, GPR, ensemble methods, decision trees, and neural networks. And for clustering, we have k-means, fuzzy c-means, hierarchical, Gaussian mixture, hidden Markov model, and neural networks algorithm. Here introduce the fuzzy logic. What is fuzzy logic? It deals with reasoning that is approximate rather than fixed and exact, in contrast with traditional logic theory where binary sets have two valid logic, true or false. Fuzzy logic variables may have a truth value that ranges in degrees between 0 and 1. Fuzzy logic has been extended to handle the concept of partial truth, where the truth value may range between completely true and completely false. Fuzzy logic process consists in four main steps. The first one is to fuzzify the inputs, then we apply rules. The third step is to aggregate outputs, and the last step, defuzzify outputs. So here we conduct a comparative study between cloud providers. So as you can see here, we have Amazon Web Service provider, Google Cloud Platform provider, and Microsoft Azure Cloud provider. According to Gartner Magic Group, this study shows that Amazon Web Service, Microsoft Azure, and Google Cloud Platform are dominating the cloud industry. Here in this table, we mention the advantages and the limits of each provider. So Amazon Web Service is more mature and present in the market, provides a computing capacity larger than all the other providers, but its limits is that it is high cost. Google Cloud Platform is low cost for both processing and storage. It has full access to Google products, but its limits is lack of services, relatively new and still in development. Microsoft Azure Cloud has data centers in more than 54 regions. It has more than 200 services. It is low cost, and for both processing and storage, it has the best disaster recovery system. Its limits is that mostly supports applications that are based on Windows. So according to this comparative study, we note that Microsoft Azure Cloud provides more services at lower costs compared to Amazon Web Service and Google Cloud Platform, and it has the best disaster recovery system. So in our contribution, we opted for Microsoft Azure Cloud. Here, a comparative study between big data frameworks. These are the major big data frameworks, which are Apache Flink, Apache Storm, and Apache Spark. Apache Flink is hybrid batch and stream processing. Its supported languages are Java, Python, Scala, and R. It is low latency and exactly once processing. Apache Storm, its supported languages are Java and Clojure. Is pure stream processing and at least one processing. Apache Spark is hybrid batch and stream processing. Its supported languages are Java, Python, Scala, and R. It's low latency, interactive queries, exactly one processing, streaming to the application, stream-to-stream joins, and it has its own machine learning library, which is ML Spark. So according to this comparative study, it's obvious that Apache Spark have the more advanced features than the rest of the frameworks, and it comes with its own distributed machine learning library, which is Spark ML. So in our contribution, we opted for this framework, which is Apache Spark. So in this slide, we introduce the ETL process, as our contribution is part of the ETL process. So what is ETL? It is a type of data assimilation process for gathering data from multiple data sources and converting it into one common format in order to build a data storage system using the 3 steps, as the name suggests, that is extract, transform, and load. Extracts means to collect the data from all data sources are required. Transform means to convert the data from multiple sources with multiple formats into a single common format. And load means to store all the transformed data into the data storage system. Here is the algorithm that the machine learning algorithm that we used in our contribution. It is the fuzzy C-means algorithm, which is a fuzzy version of K-means algorithm. Membership degree function is used to indicate the extent to which each data point belongs to each cluster. So given a certain data set, by selecting a threshold on the x-axis, the data is separated into 2 clusters. This is when K-means is applied. While when fuzzy C-means is applied, the red marked spot here belongs more to the B cluster rather than the A cluster. The value 0.2 of M indicates the degree of membership to A cluster. So the fuzzy C-means algorithm is composed of 5 main steps. The first one is to select an initial fuzzy pseudo-partition. Repeat, compute the centroid of each cluster using the fuzzy partition. Update the fuzzy partition until the centroids don't change. So here are our data sets, which we use in our experimentation. So the first data set is UNSWNB15, and the second one is CTU13. Each data set contains normal connections and attacks. For example, the CTU13 contains 13% of normal connections, more than 52% of airbot attacks, 0.48 of nearest attacks, and so on and so on. So here is our proposed approach. So given our 2 data sets, which is UNSWNB15 and CTU13, the first step is to converting incoming files from CSV format to Parquet format. Then the second step is preparing data, which consists in feature selection, eliminating redundancies, joining data sets, and extracting and scanning the string data. The last step is training and test using the FCM, the fuzzy C-means algorithm. So as we are a part of the ETL process, so the first step, which is the first step extract, consists in converting incoming files from CSV into Apache Parquet format into Microsoft Azure Blob Storage. The second step of the ETL is transform, which consists in feature selection using the AFCM method to select attributes with best gains. The second step, eliminate redundancies, which consists in removing all the duplicated records. And the next step is full outer join, which consists in returning all matching records from both datasets, whether there is a match or not. The step load consists in extracting and scanning string data, which consists in converting attributes from string to integer using the transformer string indexer. And the last step is applying the FCM algorithm and generating data records clusters. So here is our Azure inside cluster. It has 4 nodes. 2 are head nodes that orchestrate jobs, and the other nodes are worker nodes that process data. Each node has its own characteristics in terms of CPU, memory, storage, operating system, and costs. Here are the AGS, intrusion detection system evaluation metrics. There are 4 metrics. The first one is accuracy. It measures the precision across all labels. The precision is a proportion of correct labels that were classified over all labels. The recall is a proportion of correct labels that were classified correctly over all positive labels. And the F measure is a harmonic average of precision and recall. Each metric has its own formula. TP means true positive, TN true negative, FP false positive, and FN false negative. Here, the Spark evaluation metrics. The input rate describes how many events were loaded per second by Apache Spark, and the processing rate describes how many events were processed per second. So at the end, our proposed approach gives good results in terms of accuracy and detection rates. Here is some areas where it can be further improved. First area is to apply real-time stream processing. Next one is to choose a new big data framework such as Apache Beam. And the third area is to apply deep learning instead of machine learning for intrusion detection. So thank you very much for your attention. If you have any questions, please do not hesitate.
Thank you, Doctor, for your presentation. Is anyone having any questions? So I hope no questions. Thank you once again. Let's move on to our next presentation.
Thank you, Elena.
Let's move on to the next presentation by Sanjukta Buddhi, the Energy Resources Institute, India. Hello, Doctor. Are you ready with your presentation?
Yeah, I'm ready. Hello, everybody.
Yes, now I'm making you as a presenter. Please share your screen.
Can you all see my presentation?
Yes, Doctor. We'll be able to see your screen. Please make it as a full screen. Yeah, perfect. Please continue with your talk.
Hello, everyone. So am I able to move my screen? Just a minute.
Yeah. You can just click on the right arrow to your screen.
Hello. Yeah. Good afternoon, good evening, good morning, all. I don't know what is the timing over in different countries. Well, my talk will focus on a different approach, that is a biological process to produce the biofuel, that is ethanol. So I am working as a scientist at the Energy and Resources Institute. My expertise domain is biotechnology. So I will be speaking on production of bioethanol using a biological approach. As we all know that the energy demand is rising concomitantly with rise in population, and it has been projected that in coming 2 decades, energy demand will rise by around 40%, global energy demand. And in India, if we see, around 98% of this fuel, mostly in the transportation sector, is being fulfilled by using the fossil-based resources. Only a very small fraction is used, that is, the biofuels are used in this sector. And to meet this demand, India imports around more than 80% of crude oil. So the concern here is that not only that energy demand is being fulfilled by using the fossil resources, but also the associated greenhouse gas emissions. So with an aim to reduce these greenhouse gas emissions and to, if not fully, partially fulfill the energy demand, nationally the focus is being, not only nationally, even the globally, the focus has been shifted towards the renewable energy. So ethanol is one of the biofuel, that you can say the green fuel, that has got global attention as a green and clean fuel, basically due to two reasons. One, this is compatible to blend with the gasoline, and apart from that, the potential of this fuel to reduce this greenhouse gas emissions. So ethanol can be produced through the biological route using the select microorganism through fermentation route by using the carbohydrate-based feed or the raw material. Unlike the fossil-based resources, this biological process, the biofuel production through the biotechnological route, does not require any fossil-based resources. So currently, the Indian national policy on biofuels advocates an indicative target of 20% ethanol under this ethanol blended petrol program by 2030. However, currently around 7 to 8% of the ethanol is available. So the focused approach is being taken up by the researchers, scientists at every level, at the national level, to develop technology for ethanol production from a range of feed, whether it is the sugar, whether it is the agri-biomass residue, that is the lignocellulose biomass, whether it is any the spent organic matter from the industries like the sugarcane industries, starch industries, spoiled food grains, and all. So the policy is aiming at 10% blending by 2022 and 20% by 2030. So at TERI, we have started this research on developing a process for ethanol production through the biological route around 3 to 4 years back. Because our main concern was to produce ethanol using broad spectrum feed, so we have started our work by isolating a very good high ethanol yielding strain. We call it as ethanol-genic microbe. So for that, we have taken out the organic feed-based samples like ripe banana and any organic-based feed and cattle dung, and we have followed the standardized protocols for isolation of the microbe, and then we have functionally screened all these microbes with respect to their ethanol production performance, rather we call it ethanol titer. When we say that a range of substrate, that means when we consider lignocellulosic biomass, then that biomass contains C5 and C6 sugar. So a few microbes, they use C6 sugar, few use that C5 sugar. So it is very much essential to isolate or select those microbes, those have a range of broad spectrum sugar utilizing potential. So we have, like I have mentioned in my previous slide, we have collected these samples and grown, enriched those samples in select growth media by referring the literature. And then we have allowed these samples to incubate under a defined temperature for a defined growth period, and till that growth was observed. And of those consortia, that the microbial consortia or the mixture of consortia what we got, we have monitored for their ethanol production potential. and those consortia which gave high ethanol production from the sugar initially, we have taken that for further purification, isolation, and then selection of a high ethanol producing microbe. Our target was to isolate a high ethanol producing yeast strain. So we have got around 10 very good yeast strains, and we have purified and screened functionally, like I have mentioned, by using this initially the glucose or the synthetic glucose as the feed. And one isolate that we have designated as TERI-DC gave us very comparatively maximum ethanol production from this sugar. As you can see, this is the scanning electron micrograph of this selected strain that gave us high ethanol production from synthetic sugar. So this is the molecular, we have done the morphological and molecular characterization of this strain. And then we have identified this strain based on the 18S rRNA gene sequence analysis. And we saw that this strain is identified as the Candida tropicalis. Hence, we have designated this as Candida tropicalis strain TERI-DC. And the next task was to find out whether this microbe is pathogenic, because once any microbe will be pathogenic, then those strains will not be suitable for the industrial scale application. So we have carried out the pathogenic analysis using mice as the model, and this strain was found that it is not pathogenic. So subsequently, we have optimized the process parameters, having said that ethanol is produced through the fermentation route by using this microbe. So the fermentation happens under defined environmental parameters like pH, temperature. So we have initially optimized this temperature for this microbe to find out at what temperature this microbe will produce maximum ethanol. And we have observed that this microbe produce maximum ethanol at 30 degrees centigrade. The next interesting aspect of this microbe is that this is a moderately thermophilic, or it has a high temperature tolerance range. It could grow and produce ethanol if you see at different range of temperature starting from 25 to 40 degrees. So this is one of the positive aspect of this strain. And we have eventually optimized this pH for this strain to monitor the ethanol production profile at the moderately acidic pH, which is around 5.5. This strain produced maximum ethanol from this sugar, and so optimum pH and temperature for this strain was found to be 30 and 5.5, and we got around 8 grams per liter of ethanol from 2% feed, that is the sugar. So subsequently, we have upscaled this process under the standardized condition in a controlled condition in a bioreactor. So initially, we have upscaled in 3.5 liter working volume, 3.5 liter bioreactor. This is connected with the SCADA system. We have controlled this the temperature 30 degree, and the initial pH of this process was set at 5.5. And we could see that the results could be validated at this scale. And subsequently, we have further scaled up this process in a 13.5 liter bioreactor, where the working volume was 9 liter. So we have used around 3% of commercial sugar, because our main aim was to reduce the cost of the process, not to use any high analytical grade feed. So we have subsequently used this commercial grade sugar to produce ethanol by using this select yeast strain. So in 13.5 liter bioreactor, we have successfully scaled up this process for ethanol production from this commercial grade sugar. and the titer we have observed is around 12 gram per liter, and the yield efficiency was good, which was 80% compared to the theoretical yield efficiency. This is the fermentation profile of this select strain Terry DC. As you can see, the ethanol production, this is the glucose profile. We have used around 3.5 to 4% of sugar. So ethanol production gradually increased and reached with respect to the cell growth. And the intermediate metabolites that we have observed was a small proportion of acetic acid and CO2. And eventually, we have monitored the ethanol production or the titer of this strain by using different substrate concentration, using this commercial grade sugar as the substrate. As you can see here, this strain could grow even at high substrate concentration, starting from up to 15. Of course, the maximum ethanol production was observed with 9% feed, which is around 31 to 32 gram per liter of ethanol we have observed with this strain, and with 12% substrate also this strain could grow and ferment this commercial grade sugar to produce ethanol. So this is also one of the positive aspect of this strain, because in industrial scale fermentation we normally require those strain which could ferment relatively at a wide range of temperature and with high substrate, ferment high substrate to produce ethanol, so that the process can be eventually taken towards the fed batch and the continuous mode of operation. So this is a very good strain and it has a very good potential to produce ethanol in a large industrial scale. This I have already explained. So our next task was, because the current biofuel policy advocates on use of a range of feed to meet this ethanol demand, to reach this ethanol blending target by 20%. So the essence over here is to use a range of substrates. So eventually we have tried to use different feed, that is the aquatic plant feed. Water hyacinth and azolla we have used as a feed. Water hyacinth is a aquatic weed, and it is generated in a large quantities in aquatic bodies, and this is essentially a waste biomass, but this biomass contains around 50 to 60% of carbohydrate. So this carbohydrate can be used as a very good feed for the biofuel production or bioethanol production. So we have used this water hyacinth biomass as well as a feed to produce ethanol. And apart from that, we have also used azolla. Azolla is a fawn. It's a fawn. It has a very good potential biomass generation potential. It has a gestation time of around 6 to 7 days. So both these biomass we have used. Azolla also contains around 50 to 55% of its derivative of carbohydrates, mostly starch. So these biomass samples we have dried, and after drying, we have done processed this biomass for the mild acid treatment using sulfuric acid. So we have optimized this process parameters for mild acid treatment of this biomass, and we have got around 1.2 to 2% of this sugar. This is the fermentable sugar from this biomass using this approach, and by using this hydrolysate, that is after treating with the mild acid, we have used directly as a fermentation medium to produce ethanol by using this strain, the Candida tropicalis DC strain. Initially the yield efficiency was less. So the reason for this is because this biomass also contains some of the C5 sugar, which is xylose. So eventually we have developed a co-fermentation process using Pichia stiptis as a co-host along with the Candida, because Candida is a very good strain that could utilize starch and hexose sugars, including glucose, commercial grade sugar and all. But it could not utilize xylose maximally to produce ethanol. So we have developed a co-fermentation process by using Pichia. Pichia could utilize or feed on the C5 sugar. Candida could feed on the C6 sugar. So we have developed this co-fermentation process. The ethanol production efficiency from this process we found around 66%. So to sum up, around 90 to 94% of ethanol yield efficiency was obtained by using this very robust strain, that is Candida tropicalis DC, and the feed was commercial grade sugar. And apart from this, this strain could also utilize Azuela water hyacinth as well as corn cob. We have also developed a process, a similar process for bioethanol production by using the corn cob. It is another lignocellulose biomass, which is also a very good potential feed to produce bioethanol. So the co-fermentation process we have developed, and another approach is that the host which we require for ethanol production in a large scale, that strain must be having high solvent tolerance limit. So this strain could grow even in the presence of 6 to 7% solvent and ferment the sugar to produce ethanol. So this is also another desired trait for the industrial scale production of bioethanol. So this strain is a very good potential to implement for production of bioethanol at industrial scale. So Divya Mudgil was mainly working on this aspect. She has contributed for this isolation of this yeast strain, development of this process. Dipti has contributed for analysis, and we acknowledge gratefully to the entire team. And funding support for this study was provided by the Department of Biotechnology, Ministry of Science and Technology, Government of India. Thank you very much. If there is any query, I would like to take it up.
Thank you for your presence and presentation, Doctor. If anyone having any questions? I hope no questions. Thank you once again, Doctor.
Oh, yeah, thank you.
Let's move on to the next presentation by Dr. Alexander Rudnik-Milanoko from Rudnik Urbanism Design Architecture, Serbia. Hello, Doctor. Are you ready with your presentation? Hello, Doctor. Please click on the mic button to unmute yourself. Hello, Doctor. Please click on the mic button. We are unable to hear your voice. Hello, Doctor.
Do you hear me now? Yes.
Yeah,
Okay.
yeah, we can hear. Yeah, I'm able to hear your voice.
Sorry, I have some problem with the screen. I could not upload my work. I sent you on the email.
No, now I'm making you as a presenter. Please share your screen.
Okay, I can now share. Yes.
Yeah.
Yes. Okay.
Doctor, click on the share button too. Hello. Yes.
Yes. I will put it. Okay.
Yeah, okay.
Okay, do you see now? Yes.
Yes, we are able to see your screen.
I put it in a screen mode. Is it okay now?
Yes, doctor, we are able to see your screen. Please
This
open your
is
talk. Sorry, doctor, please click on the presentation.
yes, I will. This is presentation, okay? Sorry.
Yeah, doctor. Please open
Yes,
your presentation.
yes, I just open it, but I cannot see it, okay? Recording in progress. Just a second, sorry.
Okay, doctor.
I must go back on the screen sharing. Okay.
Okay, please again click on the screen button to share your screen. Yeah.
Yes, this is my.
Yes, it's perfect.
Is it open? Yes. But it is two pictures.
Yeah, doctor. It is visible now.
Okay, I will manage it. Just a second, sorry.
Hello, doctor.
Yes, yes. Just a second.
Yeah, we'll be waiting.
I cannot see my image here.
Doctor, please minimize
Yes, yes.
the GoToMeeting app. Please minimize the GoToMeeting app and open your presentation.
Okay.
Or you can share your file to your concerned program manager if you're having connecting problem.
Yes, I
Share
can
your
open.
if you're having any problem with the file, you can please share your file to your concerned program manager so that we can able to make your presentation.
Yes, I can hear you, and I will.
Yeah, we can able to see your screen now.
Do you see my window screen?
Yeah, we are seeing your screen. Please open your file. You can just minimize. You can just minimize a GoToMeeting app so that you can able to open your file. Yeah, hello doctor. We are having your
Yes.
file with Michael John. So I will be making Michael John as a presenter so that you can present
Okay,
your.
I have a
Yeah,
problem. So
it's okay. So I'm making Michael John as a presenter. You can go with your presentation. Just a second, doctor. Hello, doctor.
yes,
Can you able
yes,
to
I
see the
can.
screen?
Yes, yes, okay.
Okay, please continue with your talk.
Yes, sorry about this inconvenience. I don't have so much experience about the webinars. I was at many, I was lecturing many in live, but not as a webinar. So I apologize to all for this problem. My poster is about green building. Green building is a part of design that in construction or operation reduces the elements that have negative impacts and create positive impacts on our climate and natural environment. Green buildings preserve precious natural resources, and this design is made like a green building. It's a multifunctional design that could be used as a hotel or some public building or some mall and etc. So the main characteristic is that this building is energy efficiency and efficient use of energy and water and other resources, and also use of renewable energy such as solar energy in combination with solar panel integrated with the green roof surface. Pollution and waste reduction as measures are also incorporated in this design. So waste reduction waste is collected as an automatic waste collection, and also the quality of design is inside some detail and some element about the facade. So one of the most convenient system is a double skin facade, and despite that this building could be placed at hot air climate, it could be possible. There is many research in this area that could lead us to the double skin facade as a perfect example for integrated facade that could reduce energy heating in the design in the building. So above the 3D visualization, you have some extracts from research from my colleagues from some world university. One of them is from North Carolina, and also it is a colleague from Hong Kong, and they are all make some deep research about the impact on heating of the building. And so the first figure on the left about the 3D visualization is about orientation of the building. So the building who has the orientation to the north or south is the best example for a double skin facade, as well as the double skin facade possibilities to be open or closed with the system. So during the summer the system is open, and during the winter it is closed. So the possibility is with the data very good to integrate this kind of system in the building in the GCC. Also, the roof is a flat roof, but if we combine the greenery and solar systems as one integrated system, there is many possibilities in that combination. The figure number 3 above the images are showing that the system who has integrated solar system with the green roof are much better in performance than just the roof with the solar system, because overheating of the system during the high temperature. This building or any building that could be made in GCC is in this moment it is with the special integrated system for recycling the water. So this building has several crucial points. So the green is the perfect example and the perfect characteristic of this building, because green today is not just greenery. Today, every construction has some integrated systems, and this poster is about the green system that are presented as a facade, as a rooftop with integrated solar and green roof systems, so as well as the recycling system. And of course the waste could be collected with the trucks, but we are aware that the trucks in city cores are a great of possibility for pollution. So the automatic waste collection system are the future. There are several producer or several brand from Sweden and Finland and some other country, of course, but as Sweden has the first system in the world with automatic waste collection that was presented in 1961. So it is almost 60 years that this system is in building, presented in cities and in public building, and from time to time this system will be much more integrated in the infrastructure of any cities and any building. So the system could be with the feedback effect, a positive feedback for evaluation for better climate inside and outside the building and inside the cities. So the truck will be just outside the city core, because those systems are with 2 or more miles with a plumbing system that could collect waste and with speed about 90 kilometers per hour could bring those waste outside the city core. So the international webinar on smart grid and green energy system is the great chance for me to present not just a building that my team made as one unique Falcon building that could be placed at GCC. It is the chance to inform my colleague that every previous lecture that was about renewable and green system and energy efficiency and all the lectures that we are heard, that this part of the session is of course very very interesting, because the building are that what we see, and all the system that was presented from my colleagues was something that is incorporated in the infrastructure of the cities or the buildings. So my message for with this poster is that every building that we will design in 21st century have to go this way, and the building who will have not this integrated system will be a problem for all of us because of the producing the CO2. And so this poster and this magnificent conference is really a great chance to send my message about the needing for green building in our environment, and a green energy system that must be integrated in every building that we will develop in our beautiful planet Earth, that could be much more beautiful with respecting the themes such as green building and green architecture, and of course supporting for every conference that has this subject. And I'm really thankful to Coalesce for organizing this this conference, because I think that this is maybe the last for this year, but I think that with such an interest for this team, we'll be in situation to see you next time or next year in a similar team. Thank you all you for waiting to my poster. I apologize again for technical difficulties, but this poster will be present at my website and at my LinkedIn profile. So everyone who wants to share or to use or to cooperate upon this subject could contact me. And again, thank you very much for listening to me, and apologize for inconvenience.
Thank you so much, Dr. Alessandro, for your presence and presentation. Is anyone having any questions? I hope no questions. Thank you, Doctor, once again.
Thank you, Elena.
So by this, we came to an end of day 2 webinar, and I would like to thank all the attendees and participants of today's webinar. Hope you enjoyed the webinar and gained knowledge from the sessions. And we'll be glad if you could join us in the next webinar, which is scheduled, and dates will be informed to you by email. We will be very happy if you could share your opinion and feedback with us. Have a nice day.
Thank you. Have a nice day.
Bye-bye. Have a nice day.
Bye.
Thank you. Bye-bye.